current system. So anyway, well, so I think now I'm already late, so that's great. So today we're going to get first starting with feedbacks from the team, Ameriflux team. So we're going to have three short talks by Paul Inkerbrandt remotely. Hi, Paul, thank you for joining, and Catherine from the Utah Department of Natural Resources. I don't see Alfonso, but so maybe Patrick will be next from the Woodwell Climate Research Center, and then hopefully Alfonso Zambrano from the Smithsonian Institute will join us. Then Sigrid will tell us about the site visit process. So as you saw yesterday, we had a site visit process in place pre-COVID, and in conjunction of a perfect storm, both the growth of the network and not being able to travel physically to site, we put in place the Site Visit 2.0, which is really focusing on the data processing. So Sigrid will tell us a little bit about this. And we'll have a coffee break. Again, my favorite acronym, the bottom. After that, and then Gilberto will tell us about the processing that we do, the one-flux processing standardized across all the networks. Then lunch and the calibration lab, Ameriflux lab, about 5-10 minute walk from here, so we can bus or walk would be nice, but we can, and then we'll wrap up at 3:30. Oh, I was going to ask Deb to introduce herself, but she just okay. So
she said she was planning to.
So yeah, so we'll have Deb introduce herself afterwards. So I guess we could start, Paul. And when you start, please do introduce yourself also, and then we'll go next with Patrick. So let me know if you can share your screen. You can hear us well, and I hope we can hear you too.
Can you hear me okay?
Wonderful.
Great. I'm Paul Inkerbrandt. I'm actually a hydrogeologist with the Utah Geological Survey, which is a subset of the Utah DNR. This is a presentation that Catherine actually made up. I can't take full credit for it, or any credit for that matter. And she presented a very similar version of this at a recent meeting in Minnesota, an AMS meeting. So, but it fit what you guys wanted so well that I just wanted to recycle it. And I'm trying not to be too lazy, but I thought it was perfect for it. So as a disclaimer, and I think it's important, when we're hydrogeologists specifically, we're not micrometeorologists, but we're very interested in the pathways of water, especially in the critical zone. And we spend a lot of time measuring it. There's me taking a very technical water sample from a well discharge pipe, and Catherine measuring some discharge into a culvert there. And so we are working on creating a network of eddy covariant sites throughout the state of Utah. We have 4 existing sites, and we plan on adding 5 more, and we'll be operating a network of 9 sites with 1 additional rotating site. And our main primary interest is long-term baseline measurements of evapotranspiration. So ideally, we're going to have sites in as long as we possibly can afford to, and at least until I retire, and then somebody else will have to worry about it. And yeah, and then probably Catherine. And so one of the things we're trying to do, and one of the things we've been getting a lot of funding for, is to validate remotely sensed estimates of evapotranspiration. There's a great new data set that's been produced called OpenET. I'm sure some of you are familiar with it. They have a website where you can look at their raster data and their time series data, and they're estimating evapotranspiration using Landsat and Sentinel type data, multi-band stuff with thermal. And they seem like they're the way to go for Western states estimates of evapotranspiration, but we need more validation and checking. And then another big thing that we're kind of focusing on with our network is just making our data widely publicly available for all researchers to use. And so we're trying to focus really hard on making sure everything we're collecting is useful for even other entities. And so we're working on making sure our ergosons are calibrated for carbon, even though we're a water focused group. And all of our other instruments are in proper working order, so our data can be useful for everybody. So here's our existing stations that we've built so far. We have one at the Bonneville Salt Flats. That one is not measuring transpiration because there's no plants. And it probably has one of the smoothest surfaces of any eddy covariance station I've seen surrounding it. It's in the middle, just pretty much smack dab in the middle of the salt flats there. And then there's one in the Matheson wetlands just south of the Colorado River. It's on a point bar along the Colorado, just north of the town of Moab. That's me standing on the deck there. And my deck is paying off because right now that station has about 4 inches of water around it. So hopefully it doesn't go up as high as that battery box because then we'll be hosed. And then we have a station set up in Nephi, and that was our first station, and it produces marginal data. So we're thinking about moving it in the near future. And then finally, we have a really nice site in near the town of Wellington, and it's nestled in between 2 pivots of alfalfa, which is what's growing up all around that station there under a radiometer. And so here's our setup. For our network, we spent a lot of time thinking about instrumentation. All of our stations are solar powered, and we have a lot of redundancy on purpose. These are also producing just standard mesonet type data. And so we have young anemometers, RH temperature probes, and then we have our ergosons, 3D sonic anemometers with infrared gas analyzers. We try to put cameras on some of them. We're going to set up a PhenoCam on the Cedar Mesa in southeastern Utah. We have a camera on B-flat that produces a semi-live feed, tipping bucket rain gauges, piezometers at some of our sites, and of course net radiometers. And most of our net radiometers are NR01s. The one here is an Apogee sensor, but then we also have Apogee sensors as a backup at all of our stations with the NR01s. And then a full suite of soil sensors, mainly to measure ground heat flux, but also soil moisture and water conductance in those soil setups. And we're still kind of hashing out the best data workflow, and I'd love to hear any kind of feedback or ideas, but right now we're trying to run with what the EasyFlux DL, so the data logger program, is putting out in terms of flux estimates. And then we make sure that's properly formatted for AmeriFlux output. And Catherine's done a lot of great work kind of working with Campbell Scientific and getting that sorted out. Then we run that through a Python Jupyter Notebook script that we set up that does filtering, despiking, and checking values. And then that gets ported to AmeriFlux. And we're working on our first kind of batch of data delivery to AmeriFlux right now, with our Bonneville Salt Flat Station being our kind of test case. And then we also preserve all of our high frequency data and run that through EdiPro and look at co-spectra and look at footprints and think about that. And that's kind of our supplementary analysis. And then for our comparison to OpenET, we do aggregation and gap fill with Python scripts made by John Volk out of that group. And then all of our data gets ported immediately, kind of live streamed to EasyFlux Web, which is where we're hosting our stations for access for the farmer. Ideally, the farmer is able to use our data because a lot of our installations are ag based, and then or will be at least, and then anybody can view our data and download it and access it. So trying to make everything accessible as fast as possible, with the caveat that that immediately accessed data hasn't been proofed or vetted. And so one of the main things we're trying to accomplish, because we're comparing with these remote sensing data sets, is this energy balance closure. We have full energy balance set up at each one of our stations: net radiometers, ground heat flux plates, and of course the ergosons. And we've run into some issues getting that high closure. The issue at B flat, of course, is that area gets periodically inundated. Water's just moving around on the salt flats. It's still wet out there, and actually wind will push a little lake around, and it'll be around our station. There's one picture there, making a beautiful reflection of the mountains in the background. Another big issue in Utah is this aridity oasis type effect. This picture in the top corner is our Wellington site. And so we have two super green pivots of alfalfa in the middle of what is very much a desert. And so that contrast of conditions can be problematic for our footprint. And yeah, we're, of course, we're also dealing with just trying to keep up and learning and making sure we're doing everything right, just because we are kind of outside of our field here. And so we're pulling all the professionals in, working with people at USU, just to try to make sure we're implementing these stations in a good fashion that will produce reliable data. Then we've been interacting with farmers. I think that's key. Catherine made a questionnaire to ask about yield, water application, just questions like that, so we can compare our measurements to the data that the farmers are collecting, and look at our hydrology in comparison with the amount of water the farmers using and the amount of alfalfa they're producing. And then we're working on improving our filtering and our spike detection and just general data processing scripts. And yeah, and we're constantly tweaking and messing with our stations, even though maybe too much, just to try to maximize our measurements. Here's some more of the general problems we've dealt with. This is a picture of the Bonneville Salt Flats this last year, and it was probably better named the Bonneville Salt Lake at that time. It's just almost a foot of water in some places. Frost on our radiometer is also common in the winter because these are year-long implementations. And then here's a picture of our Nephi field deployment, and you can see the stations in between 3 pivots here, but they're all being managed in very different ways. And so we're gonna have to parse out and separate those footprints to make sure we're getting the right measurements for each field. And of course, our communications always aren't ideal. Here's a picture of our EasyFlux web interface showing warning signs or just complete station failure at every single one of our sites that day. So it's just stuff we have to drive around the state. Fortunately, it's a beautiful state, and it's nice to drive around it sometimes. So upkeep these stations. So as Catherine says, don't panic. Well, I think we can work all these things out in due time. Maybe not as fast as we want to, but yeah. And we're fortunate in the fact that we're working with a lot of great groups, especially Ameriflux, been very supportive and understanding, despite our fact that we're amateurs. We've gotten a lot of support and instruction. There's a lot of great resources available, and working with a lot of other great groups, including the Nature Conservancy. Our primary funder is Central Utah Colorado River Authority of Utah, whose main interest is evapotranspiration in the upper Colorado Basin. And so, yeah, and we've worked closely with both manufacturers of the eddy covariance equipment. Campbell Scientific is based out of Logan, Utah. And so I get to drive up to their manufacturing plant. I've done a couple of tours and interacted directly with those guys. They're extremely helpful and thoughtful. And they built all of our new stations, which are pre-wired, which is something I'm looking forward to because our current stations just look like a box full of spaghetti. So it'll be nice to have a very neat and standardized setup where we can switch out parts and anybody can understand the wiring immediately with these pre-wired configurations. So that'll be nice. And one of the things we've been working with LICOR at this site here, the Wellington site, is we've been testing the LI710 device, which is a SDI-12 communication eddy covariance. That's a single path, a single direction anemometer, but it's producing comparable ET measurements to our Ergoson, which is interesting. So we'd like to test that out some more and see how, because it's much less expensive than the Ergoson. It could be potentially implemented at standard MET stations to provide supplementary measurements of ET throughout the state. And yeah, so that's pretty much our network. I'll add that Catherine has been working with Ameriflux. We just recently did a site visit light review, which was very helpful. And we actually gave the feedback to Campbell Scientific, which is very receptive on modifying some of their inputs in their data logger programming to make sure it's standardized to meet the Ameriflux standards. And we'd love for Ameriflux to do a full site visit once we have more of our network in place. Maybe we could just do a grand tour of the state with some people from Ameriflux and visit all of these, some of the most beautiful alfalfa fields in the world, I think.
That should be a nice advertisement for the position if we hire somebody. You can tour Utah.
Yeah, that's our main hook, actually. Like, we're severely underpaid, so that's how we get people in, is the beautiful state and the fun work environment. So yeah, and that's pretty much it. Let's see how to stop sharing there. Yeah, are there any questions?
Yeah, I'm going to turn around. Questions online first, maybe. I don't see. Raise your hand if you have any question, or otherwise in the room. I have questions for you. I mean, thank you very much for the talk. Yeah, Utah has been on Ameriflux list for a long time because for the longest time, early on, there was one station in Utah, Ameriflux station, and then we worked with Steve Kannenberg to get the Cedar Mesa set. So that's something I'll ask you a little bit more later, because you mentioned that name, which is it's great if that keeps going. So, I mean, some of the challenges that you're seeing are pretty unique. I mean, the frost, the conditions, but it looks like you have a pretty good framework on your preventive maintenance schedule, and you're able to go to all the sites. But since I guess you're focusing on water and you're adding carbon as a, I don't want to say byproduct, but a little bit. What do you think your biggest challenge is going to be to maintain those measurements, especially on the carbon space? Right? And if there's any work that you do with your farmers on carbon offsets and how they're trying to minimize the greenhouse gases output from your field versus the water usage, I mean, that's probably something very hard.
Yeah. I think if we leverage the carbon aspect, it'd be mainly for partitioning purposes. We'd be very interested in plant health and uptake related to the growth of the alfalfa, and so that'd be our main interest. I don't foresee us there. We just don't have the funding sources, though we would pursue those for the kind of like variations in greenhouse gas related to plant growth. There's definitely some interest in changing crop types in terms of water efficiency. And it'd be interesting to see how the CO2 uptake changes in response. So almost everything would be kind of a side project. But ideally, there are avenues for funding for that, because we're definitely interested in pursuing that. It's just not what our primary funding sources are supplying right now. And I'll add that we will be overtaking that Cedar Mesa site once Steve lets it go this fall. So he's gracious enough to let us have that and continue those measurements.
Well, that's fantastic news. Andrew, you have your hands up? Yep.
Yep, thanks. Great talk, Paul. I really like that.
Thanks.
Yeah, I think most people that, at least in my experience, that do this are not micrometeorologists. Like, I'm an ecologist and things like that. So I was curious. There's a lot to learn about some of the advanced data processing in terms of how, even just using a program like Eddy Pro, there's a lot to unpack in there. Have you found resources within Ameriflux that you've used to get help with that? Is there contacts that you've reached out to, or is it mostly local help at universities and things like that?
It's a little bit of both. We've been just like taking in as much of the Ameriflux. Fortunately, Ameriflux publishes like a lot of their workshops on YouTube. And so we just watch those and rewatch those. There's a lot of great data processing resources available. That is one of the big hurdles that we're trying to get over, is like maximizing our ability to look closely at the data. We're a small team. And so that's going to probably be one of the biggest problems we're going to encounter, is just the personnel availability. Because we really want to spend time with the data with each station, but we're operating this network. And so, and I kind of wish we had like a dedicated PhD student kind of assigned to each station. So if anybody knows any students who wants to use our data, I would love for them to be out there. But you know, maybe that's just a pipe dream, but yeah. We've been working with Larry Hips up at USU. That's our ag school. And he's been extremely helpful in helping us with that higher level analysis.
And just to give you a little bit of comfort, I think everybody struggles with bandwidth and having the time to share their data, process their data, getting. One of our ideas with the Site Visit 2.0 program is really use us as a for the entire community, and leveraging what people have already done, because we've all been through that process at some point. We've all gained individual knowledge. So if we could make this as resources across the network, that would be a gain for everybody. But thank you. Any more questions? Let's go to Patrick. So you want to share your screen? You can do it from there, yeah, camera on.
All right, good morning, everyone. So just a reminder, I'm Patrick Murphy from the Woodwell Climate Research Center, and this is Marco Montemayor also. We are part of a relatively new project at the Woodwell Climate Research Center called Permafrost Pathways, which I'll get into in a second. But just briefly, in case you're not familiar, Woodwell is based in Massachusetts. We're a nonprofit research organization that sort of dabbles in like adaptation work, and then also trying to write and sponsor climate policy for the federal government, for like international organizations like UN. And so our newest grant is this Permafrost Pathways. We've got a pot of money from the TED Audacious project, so TED, like TED Talks. And the idea being that private donors sort of threw a bunch of money into this pot. TED Audacious decided how to distribute the money. We got quite a bit. The idea with this project, and the reason why we got this money, is because we not only want to monitor carbon fluxes in the Arctic, but folks in our organization really want to try to make a better budget of carbon fluxes, or I should say carbon movement out of the Arctic, in terms of what is that in relation to like methane emissions from cattle farming or industry or things like that. And you know, the figure, I don't have it here, but the figure that we show often is like, if China is producing so many gigatons of carbon per year, the US, Europe, where does the Arctic fall in that? Like what scale? And it's such an unknown at the moment. So taking a look at this map here, this was a sort of representative analysis that Kyle Arndt, project scientist at our organization, put together with help from Martijn Palant in the Netherlands. The idea being that like places like Alaska, where there are flux towers all over the place, littered with flux towers, probably have pretty good representation in terms of like, we know what those ecosystems are doing, and we have data spanning decades. And then there are places in the sort of high Arctic where, there haven't been a lot of measurements. And while the high Arctic might be a place where zero flux is happening, it's dry, gravelly Arctic, probably not seeing a lot of methane emissions, we don't know that. We need to be able to quantify that. So our goal is to set up towers in places that are maybe not scientifically interesting places to measure, but at least if we can get a couple of years of data, we can quantify that, build that into some models, and have a better understanding of pan-Arctic carbon fluxes. So in this talk, I just want to highlight a couple of sites. So yellow here, these 3 sites, the YK Delta, Scotty Creek, and Churchill, are sites that we're currently supporting. They are operating. And then I'll talk about a couple more in a minute.
So with the installations, it's a pretty ambitious project. We're trying to install 5 to 10 sites over the next 5 years. With that, it's a lot of logistics, getting a lot of equipment. We've all been talking about how difficult it is to get equipment in and around these places. So we're trying to get communities with commercial travel available. That way, if we're going to be doing an install, we're not going to have to camp out. We're not going to have to, be moving a lot of pieces. Hopefully we can just get stuff shipped in and then we can kind of operate out of there. Another goal of the project is making sure that these are year-round continuous measurements of CO2 and methane running on exclusively renewable energy. And then again, going back to places with commercial travel, if we're going to be working in those communities, it's nice to have some site maintenance and cleaning, which could be done really quickly. Another thing with the year-round continuous CO2 and methane measurements in the Arctic, it's very difficult to be doing that exclusively on renewable energy. We're running at very high latitudes. The sites that we're proposing are at 74 degrees north. So there's a period of 30 days where there's no sun. So, what are you going to do with that? There's things that we have to kind of come up with to, kind of work with that. And then there's other places where, you might be running only in the growing season, or, there might be somewhere that only is running CO2. They don't have a 7700. There's no line power in a lot of these places. So there's a lot of challenges that we have to kind of run through. Communicating with instruments is obviously difficult. We talked about a lot yesterday. There's a lot of different ways you can go about it. We'll get into it later, how we do it. But we've had a few issues, running with the out of the box, light horse setup. It's not really super great at high latitudes. I don't want to call out Inmarsat, but it's not.
But you are.
But it's been a headache for us at those high latitudes. But there's workarounds that we've been getting through. And then establishing relationships with the communities and First Nations is not, I don't want to say a challenge, but it's definitely an additional thing we want to consider when we're doing this, because if we want to, we want to make sure that their voices are heard. We're running on native land a lot of the time. And so we want to make sure that if we're going to be running these projects, we want to be doing it with their considerations. We don't want to just go in and barge on their land because, historically, there's been a lot of, bad blood, you could say, between natives and researchers. So we want to make sure that we're, checking all the boxes and doing it properly.
Yeah, certainly. Okay, so first site that I'll highlight here is the Churchill, Manitoba site. It had originally been installed, I think, in 2007 by Mario Tenuta and Tim Papakariu at the University of Manitoba. That was CA CF1. It ran for about a year. It was reestablished, I think, in 2009 as CF2, that time I think with methane, and then was ultimately pulled out in 2011. So we reestablished it last year because it's such a beautiful site, but it's also very easy to access in terms of commercial travel. We shipped everything up on a freight train. It's really fantastic. And the Churchill Northern Studies Center provides excellent housing and food, vehicle rentals and all of that. So we went ahead and picked a fairly standard Lycor setup, 7200, 77. We decided to go with the CSAT 3B instead of the GIL. We're logging with the GHG package. And I just briefly mentioned this yesterday, but we don't have any cell signal at this site. So rather than doing satellite, we are bouncing our data out to the science center and using their internet.
Can you see the mouse? Yeah, so here's a little radio link here.
Yeah, and you'll notice, I'm not lying to you, there is a 7500 in this picture, but because of shipping delays and everything, that's what we had available when we first did the install in August of last year. And then we went back in September and we swapped out the 75 for 72. So some challenges with the site, of course, it's a fen, it's a wetland, and it's on continuous permafrost. And so we put the tripod down, and then of course a month later it started shifting. So when we go back up in a couple of weeks, that'll be one challenge.
And the water up to our hips.
Yeah, and also it's, as the snow is melting, we're going to be in hip waders. Then the water covered landscape, of course, means that energy balance closure is really challenging. But we've, kind of come up with a couple of strategies to deal with some of these challenges and ones that Marco mentioned earlier. One is that we switch from the open to the closed path. We're primarily interested in carbon and not so much in ET fluxes, so we didn't see any problem with that. We went ahead and put up this wind turbine. This is a Primus Air X Marine. It at maximum wind is producing about 400 watts, which is really excellent. I mean, that got us through the winter. We wouldn't have been able to get any data without that. We also implemented just a couple of lines of code in our CR1000X to shut off power to the Flux equipment when the batteries were getting below 24 volts. Also really saved our butts because we had got about $6,000 worth of batteries up there, something like that.
Very heavy.
Yeah. And then just weekly checks. So those weekly checks are just, ultimately these will be emailed to us, but quick plots demonstrating, what our U-star is looking like with battery voltage, signal strength, similar to what Stephen showed yesterday for these Ameriflux sites. If we're seeing any unreasonable number of NAN values, then we know something is up. And then second site is, two sites, the Yukon-Kuskokwim Delta in southwestern Alaska. These two sites were installed in 2019 as part of a different project prior to the beginning of this permafrost pathways, but we're sort of folding them in under our umbrella. These are standard Lycor setups, so 7500, 77, Windmaster Pro, and the Inmarsat satellite that Marco mentioned has just been totally unreliable.
Challenging.
The modems die, the signal is only available like 3 hours a day or something like that. So that has been a challenge. And then again, standard out of the box solar and battery setup from Lycor as well. So I would say we tend not to have power at one of these sites from December through sort of early February. That has been a challenge, and there's currently no routine to shut off power draw, so those batteries were sitting dead for like 2 months, really not great. Access to the site, it's in a National Wildlife Refuge, and so we're getting in float plane during the summer or helicopter any other time of the year. And these are obviously very expensive ways of going about it. So ultimately, these sites are part of a different project. As I said, we have folks from our organization who camp out for 3 months in the summer, and they're doing vegetation surveys and chamber fluxes and water sampling and all of that. So the towers get a lot of attention during the summer, but then during the winter, they're kind of almost orphaned, except for a week last
A
month.
few trips, yeah.
Though I mentioned these, so one of the strategies that we're thinking about switching to Iridium or Starlink, but Starlink is really heavy power draw. We're not sure that we can afford an additional 70 watts when we're already maximizing what these solar panels and batteries can provide. Jackie Hung, the postdoc who's leading this project, is very interested in this EFOY methanol fuel cell. So one of the sites has this, and it's honestly worked very well. It's not great to be like burning fossil fuels to power a flux tower, but at the time, the wildlife refuge managers would not allow us to install a wind turbine for fear of like interfering with bird migration, which is a totally valid concern. So this was sort of an alternative. We now have permission to put that small turbine there, so we're gonna do that at the other tower that does not have this fuel cell. We're gonna leave the fuel cell in place just because it was such a pain to get it there, and it works really well. And then with our satellite communications that we have been able to send the summary files from the LICOR package back to us, so we can at least do those same weekly, daily checks if we want to, and we'll just have to pull the high frequency off every time we visit, so.
And then Scotty Creek, which was recently reestablished due to a late season fire, which just happened. So this is run by Oliver Sonnentag at the University of Montreal. The previous setup was an EC 150, or excuse me, Ergosun, I believe, and 7700. And then we were able to give them some equipment. So we gave them the 7500 77 Windmaster Pro, and our lovely gentlemen and ladies here at Ameriflex were able to give us a loaner Ergosun so that we could maintain continuous measurements as well. So we have the Ergosun running in correlation or in addition to the setup that we have as well. So we'll be able to compare, over time and also maintain what we had previously. We have no comms at this site, unfortunately. So with the GHG package, it's kind of, get the USB drive out, bring it back in. But fortunately, this is relatively close to a community up there in Fort Simpson. So we have local guardians up there, or stewards of the land, essentially, that are able to, go to the site, pull the data, send it to us, and we can do some checks here and there. Unfortunately, with the site, everything burned. You can see here, it was a late season fire, so it was, really unfortunate. We just had given them, brand new battery bank, brand new everything, and then this late season fire kind of steamrolled through everything. But it provided a really amazing opportunity for us to, re-instrument the tower and give it, a second life. And it's a really interesting data set we're really hoping to see. So this past winter, actually back in March, we were able to go to the site. We had somebody, put a scaffolding structure up. We remounted new solar panels, brand new battery bank, and then all of this stuff. The challenges that we have is, the access to the site and no comms, and that late season fire was really difficult. But with the new tower install, it was really easy to do with logistics in the winter, as opposed to if we were going to be doing it in the summer. So we were able to snow machine all of the equipment here that you see out, as opposed to, getting a sling in a helicopter, which is very expensive. But we're very excited to, compare our data with the Ameriflex data, or the loaner kit that we have there. We're discussing Starlink, but again, it's a big power draw, so we'll have to kind of look into that in the future.
Okay, and then I just want to draw your attention back here. It may not have popped out, but these two gray sites are the ones that we're proposing. We originally wanted to install them this year, but permitting is still in progress and might not ultimately happen. So 2024, fingers crossed. But Resolute and Pond Inlet in Nunavut are both areas you can see sort of deep in that like or representation part of the map. We don't know how long these towers will operate, maybe 4 or 5 years, something like that, long enough that we can establish what these fluxes are gonna look like, but they will be incredibly expensive to operate. I mean, flights up there, even though they're commercial flights, $2,000-3,000 one way, just to get there. So we'll see how these go. But while we're planning and permitting and everything like that, we're thinking we'll go with our similar setup. We're comfortable with it, but we're also maybe looking at a MeTech because they're especially the newer ones with their like updated heating. I see Joe shaking his head. But in any case.
My head at 5G.
Oh, well, hey, okay, right, which is why it's a question mark. The 5G in Pond, really a question mark. I mean, Bell Canada claims, I mean, you look at their map and they say there's 5G right here. Everyone I talk to says, yeah, don't bank on that. So that might ultimately be a satellite. However,
5G doesn't have much range.
Yeah.
The problem with it is that it doesn't, the higher frequency don't go as far, so if you can back off to 4G, you've got much better range.
Yeah. The modem that we purchased is, capable of whatever it can pick up, and we talked about directional antennas, but that's going to be a trial and tribulation. We'll see how it goes. In Resolute, I took the question mark off because our plan is the Polar Continental Shelf Program, which is a federally funded Canadian federal government program to support research up in the north. They have a sort of lab space and dormitories and offices just next to the airport in Resolute, and they have a Bell booster in their building. So our plan is to set up our modem. We're not allowed to use their network. For security reasons, they will not allow us to open ports and things like that through their network. So we're gonna set up a Bell modem in their building, and then we're gonna use that same free wavelength to bounce that Bell signal out to our tower. But like Marco said, these are 74, 72 degrees north. We're gonna see what we can do with solar and wind. We're gonna beef up our battery bank, but at a certain point, it is just simply not possible to collect these fluxes in the real depths of winter, but we're gonna do the best we can. And of course, in regions like this, it would be great to have closed path methane, but again, with our power limitations, that's also not possible. So yeah, that's us. Those are our plans. We're happy to take any questions.
Question? Yep.
A couple questions. The cost of the wind generator, roughly?
It's cheap.
Yeah, 1,200, something like that. Yeah.
And then at one of your sites, you chose the CSAT over the GIL. What's the reason for that?
Good question. So the GIL,
At that point, we were using the GIL, I think just because it was the out of the box setup, and this was
Yeah.
like before, we were honestly with some of them, we're trying to use the equipment that we had, and then once the project really got started, we kind of had like, okay, we would prefer purchasing out there.
yeah, personal choice, I guess. I've used GILs in the Arctic previously, and I always seem to notice more data gaps from a GIL.
The older Windmaster Pros really were crappy below 0.
Yeah, certainly. And so the newer ones, perhaps are better, but even
R3s were pretty good.
yeah. The Windmaster Pros that are in the Yukon-Kuskokwim Delta also, tend to have lots of gaps, and part of that's power gaps, of course, but also often, if we have SATCOMs, we can log in and we'll get some, great CO2 concentration, great methane concentration, and nothing, sonic temperature is like negative 999. So we've had great experience with the CSAT, but again, we're open to the MeTech if we decide to go that route in the future.
Yeah, the advantage of the MeTech, you can heat it, right?
Yeah,
if we have the power
If you have the
available
power,
to do
yeah, the
so.
power is the big draw.
Yeah.
And the Pro is the stainless steel version, right?
With the METEC, there's the ViewSonic 3 caged and boom, those are the ones.
Yeah, and the class A is the one with which looks more similar to the CZ3.
I've noticed also that, I mean, we have operating a couple of sites near Utqiagvik, Barrow.
Mm-hmm.
One of the issue we had was polar bears also loving to rub
Yeah.
Yeah.
against the towers.
Yeah,
So I did, and we've put enclosures, not that detail them a little bit, but
Yeah.
not very much.
We'll see, I mean, that's a concern, but also previous research projects in Resolute especially have been subject to arson and vandalism. Again, because, you know, the folks who live there are like, they see these southern scientists coming up and sort of colonizing their land and they're not happy about it, so
which
that's
is why
another.
it's really important to, you know, build trust with the communities there, because that ultimately is what's going to get you the best, you know, support and just help for what you need, because they, you know, it's their land too, they really care about it, and you just have to show that you also really care about it.
And I believe Oliver has a program funded by the Canadian government to do diversity, equity and inclusion and
Yeah,
reaching out to,
yes.
so I think you're pretty good
Mhm.
position to do this.
Hopefully. Fingers crossed.
I have one more site, the Churchill site, the CF1 and CF2, will you continue using those site IDs, or are you going to register as brand new independent site?
We're thinking CF3, but we haven't decided yet, it depends. CF2 had methane, and so maybe it would make sense to fall back under the CF2. I don't know, I mean, I leave it up to Ameriflux people, would that be better to
Yeah, what would
continue
you prefer?
using?
Well, yeah, I mean, we'll talk offline, but
Yeah.
let's have a conversation.
Sure,
in
sure, sure.
more detail.
Yeah.
Thank you very much,
You're welcome.
fascinating. Question online, I didn't ask anybody online, I didn't see anything wrong. Otherwise, we move to Alfonso. Great, you can use my laptop, I have your talk on. Okay, great, wonderful. Power, let's do this. Power. And so you join.
Yes, I am.
And then you share. Share screen. Wonderful. Okay. Yeah, that's good.
Yeah.
That's fine, you're good. Okay. Thank
Okay, good morning. My name is Alfonso Zambrano. You hear me well? Well, I came from Panama, and I will show you a forest there in the island of BCI that belong to Strike. That is a research station that the Smithsonian has in Panama. This is a view of the forest.
Is that the view from the tower?
Yes, from the tower. And the other at the end is another tower from telecommunication. Here.
I see.
This part. Okay, I will share with you today the location of the island, where it is, so everybody can know where is the place, the step that we do to maintain the data, and the challenge that we face doing the fieldwork. Okay, this is a view of Panama, and the 3 sites that we have with site for study. One in the north of the Caribbean, in the middle, and in front of the Pacific. Panama has a very variable number of rain over the year. So we have the driest place is near the Pacific. The island is medio wet, and in the north is wet, like all the year. So I will focus on BCI in the middle, in the point in the middle, where we have the tower, and we have another sensors, subflow sensor in the trees, soil sensors, temperature sensor of the soil, and ozone sensors, and the offset that belongs to the covariance system. This is a view of the island more close. This map is made with ArcGIS. It's because for pictures from drones. And the tower is just in the middle here. And we reach to the end. In this part is the location where is the user station. And we have to walk over here to the middle of the island. The walk is 50 minutes. Then, this is a closer view of the tower. The tower is, we call it our tower. It's in the middle. And we have near sapphire trees that is around to make the measurement of the sapphire. This is a diagram of the tower, what we have there. The covariance system, a phenocam, a thermocam, and another thing has a meteorological station there with, to measure the rain and the lights from it. This tower works with 2 solar system, and we have AC power in the middle of the island. So we have that advantage. This is the tower from the ground. It is 45 meters tall. Here we have a closer view of the boxes that we maintain there. This box is in the ground, where is the computer that record the information each night from the eddy covariance. So we download the data in this computer, and when we go there, we take the data and go to the server. That's the way when I start here. And now we have a radio link within the other tower that we saw first. So we have a virtual server that will load the data each hour or each day, but only the 5 minutes data that are recorded. The raw data, the 10 Hz data, is downloaded here. And in the future, we will have here a fiber optic cable, so we can download the data more frequently. I put these 2 photos because when we have a lightning strike, we have to change the PC, use the laptop while we get the other PC into the box. Now I will show you here the system on the top. I take this two because at the beginning, all are in the same box. The logger and the anemometer is here. For a better maintenance, we decide to split the places in the tower. So we have another one box for the logger, one box for the anemometer, and one box for the eagle. So we can handle better the cables. Okay. Now we're talking about the data collection. What we collect there? The CO2, the H2O, all the ways that we can record the light of the sun from the ground, from the top, diffuse light. This is and I work only with the raw data. To handle this, I only work with the raw data. So I keep working to see how when the range is out of the boundaries, or if you have some signal down. This is a CO2. The 10 Hz measure. This is the anemometer. And a challenge that we got here to do this. I take this example to show you the gaps. It's the way, or the most common thing that happens is failure of the power. In this graphic, if you saw the raw data, you only can see in this part, the sensor is okay. There is something happening here, and then the sensor seems to be okay. But sorry. After a closer review, you will see that something happened with the sensor. And this part is the same. Okay. The blue line is the power. It's the solar power. The solar power fluctuates between 40 and 12, go down and down. Then something happened here. It's not the power, it's the sensor. It's the pump of the sensor because this is an ozone sensor. And after we do some other upgradement, we try to maintain the power in 12 volts. So the sensor can work better because don't have to handle the up and down signal of the power. And from here we have the anemometer. There's a spike, but not always the spike are tell us that the sensor is bad. The system, I hope the person that process the data erase these parts. But the idea is to maintain these signals clean without disturbance. No? This one here is, let's see. Okay, this is a solar panel in the site of San Lorenzo. So you can see here the solar panels, the fluctuation, and this was in the time where in the 2020. We can go there because everybody knows why. So when we return, we change the power controller of the solar panels to maintain the signal of the power in 12. And to handle the no data and the maintenance of the site, we decide to establish a wave link between the two towers. Here is our tower, and here is the other. These are the radios between them. When the signal are in this area, then connect to the network and go to to the lab. We are working to have a better, yesterday we call it here, where we can, sorry, I missed the word, when we can has all the sensors in one place. So we have working in combine the data with all the location of the tower, the location of the PhenoCam sector coverture, and if you go closer, you can see the sensor in the trees and in the ground. Working to better the maintenance of the thing, we are working in a web page where you can only hit a link. So they download the data, the raw data, and show us in a real-time moment, some sensor and all that, what happened with the data. So you don't have to go to an other computer or take any other program to see what happened in the moment. So I can do this from my home, and then planning, okay, somebody's bad, I go to the island to do something. Right here is this is the signal of the solar radiation. Here is the IRGA. When I see that line flat and continuous, I know I have to go to the island to do something there. But while they maintain the boundaries, it's okay. So I don't have to climb the tower each time that I go there. This is the same, the anemometer. So I only take 4 minutes of the data and graphic this part, only to see so in this case, we can see in real moment if we don't have spikes. If I see some spikes, so I have to. Another thing that we can do for better is improve the infrastructure. Make a better connection in the building. This box is up in the tower. And this equipment blue here is a DC converter that can enter between 10 and 40 volts and always give 12 volts to the sensors. Well, we have to plan the change that we have to do. Before make something, we have to plan what this will work or not. But the idea of this is to have the new possibility. For example, this sensor can give me the solar power of the day. So we have another variables to compare. And what are the recurring problems that we have in the tropics? You can see the failure in the sensors, right? Because the environment, raining, humidity, lighting stress. This photo here is the last photo that the thermocam takes when the light strikes the tower. That year was the 2021. So the record. That's the last picture. The other thing that we can handle is the forest. In this part, this is our tower. Because the 2020 and 21, all the forests came close to the tower. Then we try to maintain the area clean, and the cables that hold the tower without wrenches. And the rust. This is a PhenoCam. And always, I don't know why, because we are in a good weather, but we have near the Pacific and the Caribbean, and the winds maybe bring a lot of salt and this. And I put this photo here because if we don't align well the sensor, we put the IRGA in another position, not near the anemometer, we can handle, or we don't have a way to know that it's the same wind that we are monitoring. This is how to solve the problems. Well, I from my point of view, I put these tips, no? But as how can we do something better in the site? First, always improving in the way that we back up the thing. I have 4 backups of the tower. One in the PC, one radio link communication. In my laptop, all the data is here too, in this laptop, just in case. The batteries, because we have in the tower, in the morning, the eddy covering system is connected to batteries, 12 volts. And always with the battery to avoid any fall down of the current. In the morning, the batteries are charging for the AC power there in the morning with the solar panels, and at the night with the AC power in the island. So if somebody happens with the current in the island, I have the solar panel charging the batteries. Ask to anybody what you need to do, technician. Now I will ask very much to Ameriflux team about any problem that we can have. If you have the opportunity to share what you have learned in the site, and that can avoid another person has the same problem, it's a good way to help the community. Be confident in the ability that you have when you are in the tower, because you have to solve problems that when I have to change the IRGA, I spend there 5 hours on the tower. And then you don't bring the clipper, or you don't bring the screwdriver, or you have to go down and come back the other day. So be prepared, and always I put that photo because not for any advertising, it's only to see that you have to handle the security in the place. The forest, in the tower, always helmet and be protected. Right? And when you have problems, you only have to look around and enjoy the view, enjoy the biology. That's my advisors tell me. This is a photo taken from the Finocam. So the Finocam that we have in the outer tower take every time 15 minutes, 1 photo. This camera has data since 2012. It's in the telecommunication tower, and the outer tower has another Finocam that has taken the photos since 2019. And all the photos are in the Finocam record. Thank you. If you have any questions. And here is the site. If you want more information about the site, here you can find the second links is for the page of the Finocam. So you can go there and look the island. You can zoom in and look the sensors if you want.
Thank you, Alfonso.
Sure.
I don't know, we managed to get 30 minutes today in a 45-minute talk. That's fantastic. Questions, maybe a few questions around.
How often do you have lightning strikes? It sounds like it's a regular occurrence.
Yes, each year, twice.
Wow.
Not always in the tower, but
Is there a nearby lightning rod or anything like that? Is that
no.
prohibited anyhow?
Yeah.
Well, the towers, yeah,
No,
I suppose
Top of the
50-meter
tower.
lightning rod
Yeah.
is a big ask.
Pero when the lightning hit the lightning protector, burn anything.
Okay.
Can burn it. One day, burn the cable. Another heat, pour the logger.
Yeah.
Another, pour the thermocan. So not always all get damaged, but we have always spare to change in case something happens.
Different challenges
Yeah.
from the
Yeah.
others.
And just to add that the tower is now an Ameriflux site, and it's actually 2 towers because it was moved, right? There was an old location that has for years, and now Alfonso is operating another location close by, but different in that footprint that makes sense to have a separate house.
Questions online? I think Stephen has been, Stephen and Danielle have been in all our comments, and that's great, but any questions? Okay, this is great, I think you're next. Thank you, Alfonso. Great.
Okay, let's see if I can keep it interactive, and I hope my tech team gang is chipping in where needed. Yeah, so, okay, so I'm going to say a few words about the site visits we've all heard about, and also site visit light, which is our second site visit 2.0. But to talk about the site visit light first, we have to always talk about the site visits in general. Pick off my laugh. It's hilarious. Okay, so. Arrow change,
Arrow down?
arrow down, nothing happened. Okay, so just as a recapitulation, what is the site team? What are site visits and why they're important? So for you know, our highest creed in Ameriflux is, and special tech team is to keep the high quality and comparability of sites and also to continue support the continuity of observations. In order to do that, we obviously give lots of technical support in terms of trace calibration gases for CO2 and methane, ambient and elevated concentrations. We have power sensors that we give out to sites to obviously improve the quality of the data, to do their own comparison. And we have rapid response systems for sites that get damaged, being in a storm or a fire. And we also have a profile system to promote the measurement of CO2 storage at sites that wait for canopies. And of course, the famous site visits, where we do a side-by-side comparison, where we travel with our own reference system and share technical expertise and how people troubleshoot at the site if they have any problems. So how did it all start? We're carrying out in-person site visits since 1997. And until 2019, and back in 2019 we had 554 sites in Ameriflux. Currently there are 614, and by the end of 2019 we had 174 site visits. There were years with only 2 site visits. There are years with 13 site visits, depending on how the team is growing. Our team has been growing, and if we would go to all the sites, it would take 25 years until we would then revisit a site, and which obviously is not very sustainable. It takes about 3 to 4 months of our work to carry out the entire site visit, the preparations, the post-site visits, tasks we have, and it's very time consuming. And the report span from three pages originally to 83, I think that's the longest. And the site visits were like at the beginning, they were like only a few days. People were staying in tents I learned from one of the people that did some of the first site visits. Now we obviously stay in hotels or near the site in other accommodations. And obviously, like I said, we all know 2020 something happened, so we had to come up with a different approach. But until we came up with other ideas, we had to obviously go through a whole, to get the site visit, the in-person site visits done, we had to obviously select the sites, but we also had sites that approached us. We also have a form people can fill out if they want to have an in-person site visit. And so you have to coordinate with the site teams. When are they available? When are their fluxes the highest? When are they site representative? And we have to ask for data. Are they willing to give us data before the site visit, during the site visit, obviously after the site visit? And then we have to arrange with them, obviously, access and safety at the site. And once we're at the site, we obviously have our own system, which we have to set up. Sometimes we just attach our instruments to the tower. If it's a low canopy site, like in this image, like it's a rice field, we bring our own tripod, we bring our own power supply, and you can see here. This is a generator, no, but if there's no power at the site, we bring our own generator, we have our own modem, so we are totally independent in that terms. But at the same time, we also have to make sure that we don't shield each other's sites, we don't interfere with the ongoing measurements. So in case of a tower, we have mentioned here as well, we bring our own climbing equipment, we're all trained. We have gas generator, and obviously at nearby sites here, we sometimes bring our own solar panel system to the site. And during that time, around 14 days, we try to go with site visits that have at least 8 to 9 full days, plus obviously the half days before and after with the takedown and installation. And we're always going to be nearby, so we're not setting up and come back 2 weeks later and take it down again. So there's a lot of interaction with the site teams during that time. And obviously at the end of the site visit, we ask people, the site teams, to give us their process data, their raw data, and then we do all the comparison and right at the end, the famous report that we only share with the site team. So those are not publicly, because we don't want to name and shame sites. So it's all just shared with the site team. What they do afterwards, it's there. If they want to then make it public, it's their choice. And we had some site teams that actually approached us afterwards and said, like, can we represent, can we show the figures you gave us in a conference? It's like, yes, you're allowed. It's their choice. But it's not on us to name and shame sites. Okay, so as we all know, 2020, something happened. So we weren't allowed to travel. So we had to do something as well. We had to come up with some new approaches of how to go forward, especially given the fact that we cannot visit all 600 sites on a regular basis. So what approaches can we do? What can we do? So one was to continue in-person site visits, but reduce the number. And by reducing the number, also organize little mini workshops, this one here, to promote obviously mentorship and collaboration and local regional support amongst teams. Where we still travel, we have the normal site visit, but then we invite regional PIs, let's say like 3 hours different drive or so, to decide if it's okay with the site PI or nearby, and have go do some hands-on like a calibration check of an instrument so people see how we do it, and then also discuss quality control and issues, instrument issues, data issues. And the second approach would be just to have a short-time site visit, like you see here. We travel alone without our reference system, spend less time at the site, but they would be more intensive. And then the third approach would be totally remote, like 2020. No one was allowed to travel, so we had to interact with the community just via Zoom. Everyone loves Zoom, or obviously via email. And the main goal is obviously to improve mentorship, collaboration amongst teams, people get to know each other much better, and obviously to at least visit 10% of the, or not visit, but review 10% of the sites per year. So yeah, so let's look at what did we learn and from in-person site visits and what that meant. Obviously, we have interaction, we get to know the site team. We increase the diversity of data availability for at least like that short period. We see a lot of problems by just comparing two instruments next to each other. We see how people often to troubleshoot problems they have at the site. 4 eyes see more than 2 eyes, and we all know how that works. There's a lot of brainstorming going. We can gather information that people do not submit to the MARIFLUX. We can go out and measure, we can verify instrument properties like the sensor separation. Sometimes they're off what people tell us. We go and measure it ourselves, and we can give recommendations and do the usual brainstorming over a glass of beer or so, and at the end write the report. And often there are stuff that we help them at the site and that doesn't go into report at the end because they just fix it quickly, and then it doesn't make sense to then poke at this later again. So here are some examples of what we see by having two instruments next to each other that can be overseen if you have only one instrument. And in this case, like when we start with CO2, we can see very nicely how at the beginning of a measurement period, they match pretty nicely. So you can see one is our reference instrument, the other one is the site instrument. At the beginning, you can see very nicely they measured, they were very, very close to each other, but over time, obviously one of the instruments start drifting off. So it shows how sensitive they can be to signal strength, to obviously how dirty they get and how quick they get very dirty. Some people in the Arctic, they know very well, you see an instrument, signal strength is 80%, 25 minutes later it's 35 because fog comes in full of salt. So it can go very quick. So it shows the sensitivity of some of the instruments very nicely in this example. Another example, we had a site visit with a very pronounced wind direction change on a daily basis. And in this case, we could see that at least during this period of time, one of the two sonics was shaded. So every day when the wind came from a particular direction, here's northeast, one of the two wind sensors was shaded. So these little differences we can see by having two instruments next to each other, which we would otherwise not be able to see that easily. Excuse me. So here a few other examples, which I would like to also ask you to see if you can detect what it can be. So in the first example, it's two sonics, a site that had a closed pass system, and it showed very nicely how sensitive one of the sonics was, or in this case, the site sonic is to wetness in the air. So if you have a closed pass instrument or closed pass CO2 instrument, don't think like, yes, I have closed pass, I don't have to worry about wet conditions. Well, check your sonic sometimes, because sometimes it might be the sonic that screws up your data. So that was very well visible in this case. So even with the MET data, don't assume that MET measurements in can be done on in any weather condition. So here's a very prime example we come across often is with incoming long wave radiation. You can see the gray areas is highlighted where they don't measure the same, they deviate from each other. Does one of you know why that would be the case? What's the difference between these two CNR4s? Why would they deviate? This is at night, mainly at night. Yes, but why? Why would one instrument be so?
Meter's not working.
Sorry?
One's heated, one's not?
Exactly. So many sites don't have the heater or the ventilation unit attached. And as you can see under wet conditions, how condensation on the dome is affecting incoming along with radiation. So at sites that have line power, we recommend to add that. It's only another 15 watts, the heating and the ventilation, that it's worth it. So another example here at the bottom, this is incoming power. And in this comparison, it took a long time to figure out why do our measurements and their measurements why they don't fit. So these are the red and blue lines, they are half-hourly. Half-hour values, and in gray is our 2 seconds measurements that we do. So why do you think these half-hourly values are so different? No? Well, we normally measure averages. In this case, the site was sampling. And it took a long time to figure it out. And in this case, we went that into detail and we asked the site to give us the logger code. And that's when they weren't aware of it, because you work with the same code for many years. How often do you guys check your code to see if you have any errors, measurement errors in it? So in this case, the site wasn't even aware that they were only sampling. But if you wouldn't have been there, they would not known us. And we automatically, when people submit data, we assume that they give half-hourly averages. So these are just a few examples that we came across on doing in-person site visits. So let's go to the one of the new approaches to continue doing in-person site visits, but obviously not as many as we did before. But then doing a site visit, invite regional site teams to a workshop. Let's say like 3 hours difference drive, 3 hours drive, sorry. And yes, so yeah. So what would the benefit of such a mini workshop be? Obviously, people get to know site teams from nearby. It would be only half a day because we take the drive into consideration. You cannot have a whole day and expect people to drive. Then obviously bring site PIs together, students, techs. They learn about nearby sites. They can network as well, offer each other support. And maybe during this time have like a hands-on exercise, maybe do a calibration check. So we would then bring our gases and maybe a dew point generator so people can see how that is done. They can bring maybe one site team might bring one instrument along, and then we can do that. And obviously we can discuss best practices, data processing issues, site limitations, brainstorming, and yeah, talk about QAQC procedures. So now a quiz. There are at least 2 local site teams, Daphne, Joe, Stephen, Sebastian. What do you think, how many sites are within 3 hours drive from Berkeley?
Sites. Groups.
Site groups first, sorry.
Well, we've got 9.
We just learned from Arsene was at AMS meeting, we think there's about 70 sites, at least 70 sites, not all are registered with the network.
70 or 17?
70.
Within 3 hours drive from Berkeley, California.
Yeah, Central Valley,
Yeah, Central Valley.
3 hours, I'm talking about 3 hours drive, not Central Valley, 3 hours.
Central Valley.
Sacramento.
Depends on how fast it's going.
Who's the driver?
Registered. Okay, so how many site teams are within, well, I'm talking about registered site, officially Ameriflex registered site.
Officially Ameriflex?
Yes,
Site teams. Probably 5 or 6.
there are over 20 sites, Ameriflex registered sites within 3 hours drive.
Well, 20 sites, again, we have 9.
Yes,
If you include our old ones, it's 15.
are they all active?
And 9 are active.
So here's Fresno, because I know we have someone from Fresno here. But
And
sites
Elkhorn's
around
at
Fresno does not because it
3195.
takes longer according to the map. And site teams, there are 12 site teams. But I don't know how many active because not all Piazza doesn't already take the towers down. So I know at least 2 sites in this whole cluster here that have been taken down. Yeah, but yeah. So I have another example, for example, in the summer, we'll be doing a site visit in northern Minnesota. The site visit would be at this site, US MVP. And if I would take 3-hour drive from there, it would look pretty grim because here's the Canadian border as well. So if we then go to one of the site PI's own locations to be Minneapolis, there are 2 site teams in Minneapolis alone. So if I look at the 3 hours drive, there are not many sites. So I would have to then reach out to sites around. And again, in this case, it would be 20 sites and 9 site teams. So again, it's outside the 3 hours drive. So in this case, if one of these PIs says like, yes, I'm happy you can do it my site, for example, let's take this site here, then I would then see what is around there as well and bring those in and see, hey, we would be doing this here, are you interested in joining a mini workshop? So as a study example, I brought, for example, where I live near Knoxville in Tennessee, there are 5 sites and 2 site teams. And in this case, there used to be 3 sites here, of which unfortunately only 1, a neon site is still active. And that's less than 45 minutes drive for me. So I could just like drive there. So just as an example with like trying to find how do we do this 3 hours? How do we combine as many site teams as we can? But then in this case, these are the site locations. Doesn't mean that the site teams are also nearby. So then that's the next challenge to figure out where are they, and then again reshuffle the distances. So okay, to the second one, because I need to hurry up a bit, would be a short site visit without our traveling equipment. So in this case, it would be, we would spend, that would be geographically obviously defined, let's say again, like pick, in this case, this image, this map has 6 hours drive now, just to see regionally how far can you drive within 6 hours. And in this case, it would be like 1 or 2 days only, and you would then travel to one site and spend half a day or an entire day at the site itself, do all this like measurements and brainstorming and do a calibration check if it is preferred by the site, troubleshooting, talk about best practices, and then also dedicate a lot of time to data related tasks like data processing, QA/QC procedures, help them with uploading data, show them and help them to get the data together so the process between submission and all the communication with the data team can be reduced so data comes in faster from sites and they pass the QA/QC process quicker and then move on to being published as base data. So that's the idea between just the short site visits at site, but that would be again only 1 or 2 sites depending, or if it's a site cluster, but you would only deal with 1 site team at the time. So this would reduce our travel time as well, and we could kind of like cover several sites, and then hopefully they then we can iron out problems they have and improve data quality, of course, and also support them and help them to shorten the time window from data collection to data being published in base. And then the last, the famous site visit light, which you've heard of you, and that we contacted some of your sites, and Paul had also mentioned site visit light. They've been through it. This would be just remote interaction, no site visit, no in-person visit. And obviously with that, you lose the whole interaction with the site team. You don't get to know them the same way as if you're there with them. You're not seeing the site. You have to then obviously rely on all the information they provide us, and it's slightly limited in that sense. But we can cover more sites in a year than we can then we can cover if we visit them in person. So what did we learn from the famous site visits and what can we now take over into Site Visit Lite. So we learned that a lot of instrument and data issues we can spot from just looking at the data, and also like from us actually processing the data as well and comparing with theirs. And yeah, so more recommendations that we had written were obviously data processing related, that and those instrument related we could see the data, so we didn't have to go and physically and check it. And then we would then also reduce the amount of time, our time, the site team's times, because they also have to make sure they are there when we are there. They have to make sure that the instruments are working. And so it's very time consuming. We can reduce obviously the carbon footprint by not traveling so much, because when we travel, we have about 15 boxes. We have to rent obviously bigger cars because we have to transport stuff. And we can use longer time series as opposed to the like 10 days of data we get during a site visit, and it just takes a bit longer. It takes shorter to do all the evaluation. And like I just mentioned, we can reach more sites per year because our aim is to reach about 10% of the sites. And as you have heard earlier, currently there are 614 sites registered with Ameriflux. So how does the Site Visit Lite, how does it go? So first we select sites as the tech team. That's why we have Hassan with us, who's partly tech team, partly data team. So we select sites, but at the same time, sites can also contact us and invite us to do a review on their site. So it's not only from us, not the conversation doesn't only start from our end. In this case, actually, Paul, they approached us. So, so we send out an invitation email, and this invitation email, we send a questionnaire. We ask for data, we ask for the metadata, and also images. So what do we want to hear from them is obviously what instrumentation they have at the site, the measurement height, the sensor separation, the corrections they apply, what quality control they carry out on their data, and then obviously for 1 month of data, and we want for that period, we would like to have the raw data, but also the final process data, ideally quality controlled already and not just the AD profile. And obviously with every data, you would like the user to know the heights, the heights, the sensor separation, and other information that is necessary to process the data. And it happened many times that sites in a questionnaire say they apply these and these corrections, and then if you look at their processing file when they use EdiPro, they sometimes don't match. So often it happens that sites, they believe they apply a particular correction, but actually if you look at the process data, that is not the case. So it's also for them a good verification to actually see what they do and what they believe they're doing. And then of course, because we cannot visit the site, we ask for images of the instrumentation. Sometimes we get really beautiful close-ups, and then also for the entire site, and footprint would be nice as well, just to give us an impression, how is the vegetation homogeneous or heterogeneous, and is it like, is it like a low canopy site but has lots of shrubs in between? And then obviously we ask sites to keep their site information page up to date, because very often happens that obviously site teams move on, but the contact person still remain as contacts on the site information page, and then we try to contact them and it's like, sorry, I moved on 2 years ago. And obviously to complete a variable information table, here's the link. I think most people that I've contacted in the last weeks, and I contact over 100 PIs or site teams in the last weeks and months, we would like them to complete the variable information table as well, because if you download someone else's data, you would like to know where was it, where does it come from? Did they measure at 2 meter, 5 meter, or or 3 meter, because the site has didn't keep their information page up to date and has no images on it. So you don't know, is it a tower or is it a tripod? And of course, yes, and complete the variable information table. So, so far, since 2020, we've done 21 reviews, and we still have 6 in the pipeline. And one of the biggest benefits of this concept is the fact that we can reach way more sites from outside the US than we did before. Before it was the easiest to travel to Canada, but now by doing the site visit light, we can we have sites from Argentina, Chile right now, Peru, and also Mexico that we have in our whole, that we've done already or are still working on right now. So that's a very good, that's a big improvement to bring the Marifox community together and also have more conversation going on between us, the data team, and the sites themselves. So they're not just like another Ameriflux site that submits data. So we get together names as well from these sites. So what did we learn so far from these 3 years? Because it's May, it's almost 3 years, actually more than 3 years now since we started doing these site visit lights. So obviously we can use longer time series, so we can spot pattern much better. We have more data points can do much more robust statistics than just like 8 days with gaps between rain or power. So our analyses are definitely not much better than they were before. And indeed, we still, even without having a reference system, we can still spot many issues with the instruments from just looking at the data and reprocessing the data. And one of the main reasons why we also reprocess their data is to get the spectral analyses. Because rarely we get, when people send us data, also their drives or their spectral, post-spectral information. So we can then extract those when we reprocess their sites or their data. And we can, even from just looking at the data itself, we can also spot instrument maintenance issues they have, and also include that in the report. So here are a few examples. So let's start with raw data. It's always very wise to plot raw data, like for example, the sonic graph I had shown earlier. Don't assume it works perfectly under wet conditions. So always plot the raw data. Look at if you have reoccurring outliers and ask yourself, why is this happening? And also like even plot the timestamp, because sometimes you might see, like in this case, that on data loggers, in this case, every file had a particular number of data records missing. And while when you process data, obviously, if you have less than 3%, it's fine, but it's just part of housekeeping to make sure that you have complete raw data files. So that's simple checks like this, plot your raw data. That's also what we do as well. It's the first step we do when we get data for the site visit light review. One of the biggest issues we come across are lag times, lag windows people are choosing. Many times people just go with the default values they get given if they use, for example, EdiPro, and that might not be appropriate for their site. So that's another good advice. Always, play around with lag times. See if your window is too narrow. Do you find a lag? Like in this case, beautiful. In this case, you can see nicely here how beautiful within this half an hour, it found the lag time at zero or almost zero, or is open path. Or Regason, very close, has no lag. And for many periods where you actually don't find a lag, and then it uses a default value. or it's just at the edge of your window. So that's another advice, just play around there, because your covariance might not be in the appropriate. You might not, if you use a default value because it doesn't find the lag time, you might have not the correct covariance than what you would get if you have a perfect lag time. And also the lag, they do change, be it by the instrument, because it's, for example, you have a tube, they get also like sticky over time, so your lag the lag window extends, and obviously if you're at the humid side, again, with relative humidity, we know the lag times also shift. And if you use, for example, if you pre-calculate the window, don't assume that the same window you have calculated a month ago still applies 2 months later. If you give it set margins. Like, for example, in this example here, the site was using a very, very narrow window, the dots in black, and so automatically, obviously, when it says 0, it probably did not find a lag, and the default value was set to 0. And if you give it a bigger window and remove the default value, you can see that in this case, with relative humidity, how beautiful the lag changed. So if you use optimization files, make sure they're always up to date and don't assume what you've done last year still applies this year. And so play around with lag times a bit, because if you have incorrect lag times, obviously it affects the covariance and it ultimately fluxes. So carrying on with lag times, because I mentioned it's one of the biggest issues we always come across. So at this site, for example, again, the lag window was very narrow, like plus minus 1, and default value 0. And you can see the site, these are the fluxes. It created beautiful diurnal methane fluxes. The site was very excited. They never looked at the spectra, so we plotted the spectra that in blue was their site. And then if we extend the lag window, we suddenly actually realized, yeah, there is a lag that increases. And then in this case, the site stopped in the measurements during the site visit, cleaned the instrument, and you can see the lag somehow it reset and then started to climb again regularly. And the flux has changed dramatically. But you can see from the spectra as well, it looked totally different. So play with lag times, look at the spectra as well, that does tell you a lot as well. And especially you can see the instrument, the lag time constantly goes up. So it would be very interesting to just let it run for a while and see how far they go. But yeah, if you use incorrect lag times, watch out, it also affects your fluxes dramatically. And in this case, the site was very shocked because, it's one thing if you have beautiful fluxes and actually realize, yeah, very, very low fluxes. And it's all driven by incorrect processing. So another example is metadata files, if you have dynamic ones that you can use. 5 minutes? Okay, yes. So yeah, so in this case, I had 2 site visits, or we had 2 site visit lights, where in one case, a site had sent me the wrong metadata file, dynamic file with canopy height. That turned out it was not updated. So when I tried to reprocess their site, their site data, I couldn't get a match. And it took a long time to figure out why. And also for them themselves, they realized they had not transferred the file they were working on into the main folder. So this case also helped because they weren't aware of it either. So they were processing their data in a different way than I was, because we were used to different files. And another case recently, again, I tried to follow their processing steps. I could not reproduce the data, and it took a long time. They used it. I could see if you print out use EditPro and you print out the processing file, the configuration file, you can see, yes, they have used it. When I open the file, I can see, yes, they have used it, but I could not reproduce it. And then it turned out it was as simple as using a different Edit Pro version. In this case, I did contact Lycor and did confirm that this particular version 7.08 does actually not read the file correctly. So that was as simple as that. So in the end, the site did not apply any canopy height. In this case, the canopy was above a meter. So just simple things like this can go wrong sometimes. And as a site team, you don't know it, or you don't. But by us looking at the data, looking at the processing, and sometimes because you use different version of Edit Pro in this case, we could spot this. So I decided to go back and reprocess all the data. And what else do we see in data is instrument maintenance going wrong. In this case, a dying pump. The site was not aware of that because they didn't plot the flow rate. In this case, you can see it went from 16 liters per minute down to 6, just for this one period we had the data. Then here we can see, I have to rush because I've been told, the signal strengths. The instrument was cleaned, and you can see here how dramatically the concentrations changed. In this case, the site did not spot this because they were using relative humidity, which is quite, is quite common to use in when you process the data to replace your own water channel data. But in this case, you can see how simple it was what a big effect using relative humidity had in the data versus if you use your own water channel. And this is also beautifully visible here in water vapor concentration, the difference between using just the water channel in the where's the blue line? And then if you run the data by using relative humidity. So also if you do that, run your data with or without, as well, just to verify to see what difference the relative humidity did in this case. You can see here how dramatically the difference between running data using relative humidity versus no relative humidity. And this effect you would not see if you would not realize that the signal strength has such an effect on your data and how you're masking it by using the MatStation water vapor, relative humidity, and then convert it to water vapor. And then another one, like I mentioned before, always make sure that the corrections you are applying are actually being applied. And also ask yourself, if I use the default values, are they replicable to my site, being it with detrending? Because there are various methods you can apply there. Many sites, for example, like the angle of attack is a default value. Again, ask yourself, do I have to apply it? Because those are really dependent on the internal settings of your guild. And again, there are several papers out there that show a difference if you're using or not using it on, obviously, on the energy balance outcome. So that has a big effect on that. And then play around and see how much does your data change. And also if you include or not include. And I believe in this case, this site, there's a difference between processing using the spectral corrections, because there are sites that don't apply spectral correction, because they are quite not very tall sites, not very tall towers, and versus versus applying the spectral correction. And then let's move on quicker. So here are a few secrets of the site visit light trade. What you can do yourself. So just by looking at your incoming shortwave, if you have, and PAR, what you can do, you can see if there's a tilt in your instrument. If you have instrument drift, you can see if one is over reporting. There are several papers out there where you can calculate the ratio between them. You see if you use incorrect coefficients, plot a longer time series, not only looking at like 1 week of data, plot like your whole year of data. You can see the shifts, you can see drift in those data. You can see if you use suddenly a different coefficient, if you see a jump. If you don't have PAR, you can use the incoming radiation with potential radiation, and again, you can see a tilt shift, and you can see if you have a shift in your time stamp. And we also did site visits where, in this case, we came across data loggers that were off by 9 hours. So check your clock on your data logger as well from time to time, please. When it comes to air temperature, you can obviously compare with if you have a 7700, you can compare with the temperature you get from the 7500. The same with the relative humidity, you can compare it to your water vapor channel data. And with wind direction, there are so many national weather stations in the US, you can always compare with your data with nearby stations in terms of prevailing wind direction. We also had site visits where we had wind was off by 180 degrees, so it's totally opposite. And yeah, I think I jumped over a few things. So yeah, so if you have more questions, just ask us, get in touch with us. Here you have our faces again. And yeah, I added some barcodes there if you want to play with your phone. And so yeah, that's it. Did I make up?
Yeah, that's great. 10:30.
Yeah, exactly. Back on.
Yeah, you're standing between people and their coffee, so just
Am
want to make sure.
I?
Just quick, I don't see any question in the chat. Questions here. So great, you're sitting in front of a coffee. So this is just one of the tools we have for data quality, right? And we're here to help. We're not the carbon police. So please reach out to us if you want to help.
And like I said, no name or shaming here.
Well, it's not there's no right or wrong response. I mean, the PIs know their sites, they know what they should do. I mean, we're just trying to help. That's the way it is. So thank you for your attention. This year. We'll resume at 10:45, 15 minutes break. Thank you. Okay, it's 10:45. Let's try to resume our morning session.
Yeah.
Chop, chop. Joe, we're gonna start again. Thank you guys. I'd love to see the interaction, but let's keep on schedule. A quick announcement, Alfonso reached out to me and I'm gonna also look at anybody in the room. One of the roles I was trying to fill in the site visit program is to reach out to ambassadors and people that could help AmeriFlux spread across different regions. So, I mean, Alfonso, for instance, mentioned that he'd be happy to help AmeriFlux reach out to Central America sites and help us with this. It's not limited to this. I mean, if we have colleagues working in the Arctic that will also fill up some of that role, please engage with us. That would be fantastic. That's it. Okay. I'll pass it to you. Thank you.
Right, we have 2 more classroom sessions, and the first one's gonna be about Venom. But this topic also fits into the last topic of the day, the OneDocs one. So yeah, I'm gonna have Daniel come through the Venom piece, and then yeah, we can start that on the day after the thing.
Everyone, nice to see y'all again on the second day. So let me share my screen here and get started. Okay, so I'm gonna spend the next session here talking about BATM, biological ancillary disturbance and metadata. I'm gonna give an overview and emphasize the BATM that are related to the FluxMet that are FluxMet metadata, especially because we see those as the most critical to making use of the base and FluxNet products that we're generating. So for the agenda, I'm gonna go over some BATM basics, where to find BATM, how to submit BATM, and then focus in on, again, some of these key metadata for FluxNet. And just a plug that we aren't the only people that chose the BATM acronym. This is the Bay Area Discovery Museum here locally, so go BATM. Okay, just wanted to show this beautiful figure that Hassan put together again, showing the diversity of sites in the network. And so BATM is really helpful to understand this diversity. It is a standardized format that we use in AmeriFlux, so does the global FluxNet network. We've mostly been co-developing this with ICOS, and we'd love to have more people joining in that effort. As I mentioned, it's contextual data for the sites, and I'm gonna go through some examples of that here. This is a picture of the main landing page for BATM. So if you're looking for BATM, this is under the data menu. This is your starting point. Here's some examples of BATM. This is the site general info. This is a site page. And so everything that's populated on this site page is from BATM. So if you don't tell us you don't fill out your BATM, it doesn't get on this site page for folks to see. So we really want you to keep this up to date, and we'll show you how as we go through. Here's the DOI BATM. So this is how your data sets, your base and FluxNet data sets are going to be referenced. So again, a great place to keep your information up to date for who you want on that citation list. This is separate from the site team list that UA, or I'm forgetting who mentioned that earlier, or Hassan maybe I think mentioned it. So again, great tools here to help people get the appropriate credit. And this is BATM. And then we have a lot of other things, a lot of ancillary data shown here, soil characteristics, disturbance data, canopy height, LEI measurements, sensor metadata that Sigrid talked about. I'll go into that in more detail. So just some more basics on BATM. BATM is organized into 3 hierarchies. This is types, groups, and variables. This is the BATM standards page where you can start looking at all these details. So types, for those of you that have been around for a while, this is equivalent to the old Excel templates. So this puts together the related BATM groups shown down here. And then in each group, there are a number of variables that make up the group, make a cohesive unit. Some of these variables are required, some are optional. When you click on this BATM group page, you'll get a lot of information. Pay attention to these tabs up here that help you explore the BATM variables and their requirements. Okay, where do you find BATM? Great place to find BATM is from the data download page. So when you download, you can download BATM on its own, but most people are getting BATM when they download the FlexNet products, either the base or the FlexNet-Net. So when you either download the AmeriFlex base or the AmeriFlex FlexNet product, you can get BATM on its own, which is down here. I'm going to talk about this measurement height, which comes from the variable information tool that Sigrid mentioned, so it's a little bit of a side thing going on. And then BATM is also bundled with the actual, in this case, base data product here in that zip file. You'll get both the base data and some BATM data for the individual site. These BATM here are network level, so you'll get all the sites with and I'll go into that in a second, how that looks. Okay, so when you get it bundled with, like, say, base data or in that standalone BATM network file, this is how the file is named. It's an Excel file. You'll have the site ID, or you'll have these two things. You'll have this AA-FLX or this AA-net. FLX is all the sites with, say, base data or with the FlexNet data. AA-net stands for network. It's BATM for the entire network, whether they have a FlexNet data product or not. Okay. Here's what that file looks like. And it's somewhat tricky to use, but here's the key. You use the group ID to pick out the individual groups that hang together. So I've got those highlighted here in different alternating colors. Then if you want to find out what the variable is, you can use the group name to find the bit and then go to that group, look up the variables, find all the details. And then of course you have the site ID and the value. And especially the site ID is important if you're using one of those network level files, right, to know which site the BATM is for. Okay. We have a tool that you can use to parse this thing, so you don't have to build scripts to parse it yourself. It's a Jupyter notebook. It's available on GitHub. Have at it. Okay, so I said there's this thing called measurement height. This is technically BATM. So we found that the BATM, the old BATM instrument templates are very good for very detailed information, but kind of hard to use when you want to go say, hey, this variable, what height is it and what sensor is it? So we built this variable information BATM group to create this measurement height data product. So this is going to go variable by variable in the data product and tell you what the height is and what the sensor was that was used to collect that information. And if it changes in the data record, that is noted. Okay, so you can either download this, get to this measurement height file from the data download page. So there was a metadata section there and the link is provided there. Again, it's for all sites that have that data product. Or you can go to the measurement height page itself and click this link. There's also a nice description of the headers in that file on that page. Okay, where else can you find BATM? The site search and data availability page that was recently updated is another good tool. So again, all the information you're seeing on this page is from BATM. So if you don't give it to us, we can't populate it. What's cool about this page is you can filter the sites to the ones you want, and then you can click this export results button and get this time it's tab delimited, but it is a ASCII file that you can read to export basically the table that you're seeing here in the results. So that's a good tool. The other thing you can do is, I didn't highlight it here, but this button here says save as site sets. So if you filter again your sites to the particular sites of interest, you can save them as a site set. This does require that you be logged into the Ameriflex website with your account, so we can keep your site sets for you. But what that looks like is once you have your list of site sets, there's a bunch of tools again here that you can use to get different types of BATM information out. As shown, this one's the citation link, which is actually a zip file with all kinds of different citations in different formats. I'm showing you the CSV file here. Okay, so let's transition to how to submit BATM to Ameriflex. So this is linked from that main, this page, the submission instructions page is linked from that main BATM page. So there's a couple different ways that we ask you to submit BATM to us. So I'm going to step through those now. So first, I'm going to start with registering a new site, which most of you, I think, have done. But basically, you click each of these buttons and you'll see the instructions for how to do that. So if you were to click the show registration instructions, you'd get details on how to download this site general info Excel file, which I think many of you probably have done. Once you fill it out, you submit it via the upload data page, selecting the BATM option there. And just a tidbit, you select, I don't have a site when you're first registering the site. Sometimes people, that tidbit is in the instructions as well, but good to remember. Okay, the other place to submit BATM are the online editors, and you can get to this. I'm showing a site page here, and on this BATM tab over here, there are a bunch of useful links. Two of them are the site general info editor and the DOI authorship editor. So these are the places where once you've registered your site, we want you to keep your site general information updated with this online editor. And if you want, also, it's very similar for the DOI authorship, which is what I'm showing here now. So it's like little cards that come up, and you just add cards if you need to add more people, or you can edit cards that already exist, you can delete cards. And then again, it kind of shows which BATM variables, these are groups, like this is a group, DOI organization, this is another one. And then for the different variables, which ones are required and not. I want to say also, like, stop and ask questions, interrupt me. I'm going to fly through this and then we can discuss that if there's confusion during stopping. Okay, so for most other BATM, accepting variable information and variable aggregation, which I'm going to talk about in a minute, we would like you to use the CSV customized files. So this is just a very quick overview. We can talk about this in more detail if you want to in the time we have left. But basically, you go to the main BATM landing page, you get to the submission page, you have a look at the standard, you find the group you want to submit, you read about it, figure out what variables you want to include, and then you can customize a template to download that you can then fill out as a CSV and then upload. Once you have that via the regular upload data page. Okay, so now that's it for submission. Now I want to talk more about BATM for FluxMet data. So remember, FluxMet is both the base and FluxNet products. So starting again, just a reminder, you all know this, all sites are very different. So it's really critical that we understand where the different sensors are on your towers, the different naming conventions that you're using for the different variables. You're using the same naming convention, you're just which names are you giving to the data streams that are coming off these sensors, right? And the way to do that is going to be through this variable information. And then the variable aggregation is the next step to think about to get into the OneFlux processing. Okay. So I'm going to talk a little bit about variable information, and just a reminder that this is the information that gets put into that measurement height file. And then the variable aggregation is used behind the scenes for OneFlex processing. Okay, so this is what the tool looks like. It is customized for each site based on the site's history with the network. So there are instructions, detailed instructions at this link. There are a short video here showing you how to use the tool. There's a quick overview of steps here on the right. Have a look at them if you're new to this tool. And then another note, you have to have an Ameriflex account to access this, and you have to be registered as a site team member. We lock this down more so than some of the other online tools. So, and you have to use the same email. So your FlexNet account or your Ameriflex account email has to be the same as the email that you put on your Ameriflex team membership. So, okay, so the main goal with this tool is that your submitted variable names are, there is a one-to-one match with those submitted names and this FPN column on the tool. Okay, so I'm just showing you the FPN column, and FPN that's the way you submit variables to match the FP standard. I don't think we said yet that FP stands for flex processing. It's the global standard that Ameriflex has developed with its other global network partners that all the products follow. So we're just saying, in order to get your product in that final standard, we need you to give us the FPN, like reporting format standard. Okay, so that's the column you want to focus on with the one-to-one match. Here's some tricks for where you can remember where your submitted variables are. So when you get the format QA/QC report, when you've uploaded your data, right, you have these links to the online reports that can look like this. Down at the bottom of that report is a readout of all the variable names that we detected in your submitted file. So you can have a look at that, and that's what basically we want you to one-to-one match to. Okay. The other place you can get it is you can go download your data from Ameriflex, the base data here, if you've already have a submitted, if your data has already been published as base, in this case. And the only caveat with this approach is we need you, when we publish your base file, we add a qualifier, it's the PI qualifier, to certain variables. It's the anything you've gap filled, and then it's the post-processed variables like GPP, NPP, RECO, and PPD are the variables that we add, and also if you aggregated variables. So if you give us a variable name that's _1_1_A, so it's like aggregating replicates together, we'll also add it to that variable name. So we add that, but we don't want you to put that on the variable information. It'll complain. So that's the only caveat here. It's not a one-to-one exactly with the base. It's what you submit to us. The difference makes sense. Okay, as I mentioned, the tool has a couple of flavors based on your history with the network. If you had data published with the network before AMP was established, then you get a table here with some gray columns on the left that can't be changed. So those are all the historical submitted data that we're aware of. And so the idea here is that when you match that FPN column with your submitted data, we give you a chance to say, hey, that old historical data is now this new FPN name. And so if we have a kind of a trace back of like, hey, the old versions of Ameriflex data products were linked to this older data that is floating around out in the ether somewhere. Okay, so if this becomes cumbersome, talk to us. We can help you find workarounds for it. Sigurd's really great at advising on that. But it's from a data preservation standpoint, it's a nice to have, but it's not a requirement. Okay. If you have not published with Ameriflex before AMP was established, you get a clean slate. And the tool is actually a bit easier to use. You start fresh. And those are and you don't have all those gray columns. So the tool's got some really nice tricks to it. Have a look at this webinar for more details, or I can, if we have time in your interest, catch me later, or we can talk about some of those. But there's a lot of things you can do if you have sites that are very similar to one another. There are a lot of tricks for populating information from one site to the next. There's ways to copy and paste information into this tool. The information is there to help you make this as easy as possible. Okay, so I'm gonna spend just a few moments talking about variable aggregation, and I think Gilberto will run more with both the variable information and also a lot more with the variable aggregation, because it's so important for one flex processing. So this is to help us understand when we take that base file, especially if you have multiple sensors, like how are we supposed to combine those into the representative data stream for your tower site? So this is the BATM that tells us how to do that. This is how it happens. When your site's ready to go for one flex, so you gotta be CC BY, you have to have published base, you have to have the required variables in base, and typically we ask you to have your variable information filled out correctly. Then AMP will contact you by an email, and by AMP, I mean at this point, Seabird will contact you. And we will provide a pre-populated CSV file with our best guess at what we think your variable aggregation could look like. We ask you to review it. We give you instructions in the email with this nice little infographic that Rachel helped design for us. And you review it, and then if you make any changes needed, and then you upload it via the upload data webpage, again, using the BATM option. Okay, I've tried to collate all the different links that I put throughout the presentation here, but I've also tried to organize them that all these links can be found under either the data menus or the site menus on our website. And I tried to highlight kind of the key phrase that you might want to use if you're looking for that under those menus. So I'll stop there and open it up for questions, discussion.
I have a question. To submit a photo of the tower.
So submit a photo, so that, what's the process now?
If you go to your site page and click on the image galleries tab, there's a button up top that says add image, and you just add an image, and then it's reviewed by our moderation team. And then it will be published on your site page.
I can add one.
One as
One
many
time.
as you want.
And then
I mean, it
then-
is one at a time. It is one at a time, because we wanna collect a lot of information, like who took the picture, who has the rights to the image, like, is it okay for it to be CC BY, do you want me to email you if they wanna use it? And that you fill out really rich information behind each image so that, yeah, it's well documented on the website, so people know what the image is.
We would love you to add multiple.
Yes.
No, because I think was a problem, because I can do not one, and I have several, but other for one tower and other for one tower. I tried twice, a different day, and then maybe it's only one that I can put there.
Maybe you can catch one of us and we can sit
Yeah,
down with you
Pero
and try it out, see what's going on.
right now,
No, like either at lunch or
yes,
later in the day. Great question.
And I definitely encourage everyone to add. I mean, in the presentations, we saw really beautiful photographs, so if you have them, share them.
Who here has uploaded or contributed BATM? No, nobody else has registered a site?
I have.
Okay, then you go ahead.
Yeah, I just want to add a comment as well, now the point of view of the tech team. For us, when we talk, when we work with sites, we also look at those images as well on the web and also contact the BI, so like, can you please provide a better image? Because there are some sites that just show the the view from the tower, would be nice for a user to see what the tower looks like. And also with this, okay, we'll get later from that, about that, so I'll bring that, the images again into play later.
I have another comment on BADM in general, I think, Danielle, what you just went through was really well done. BADM has been the bane of Ameriflux ever since it was born. And it's getting better. I don't think it's ever going to be easy just because it's a very complicated problem to solve. And coming in as a new tower site, it could be totally overwhelming. But you know, it's a very important thing, I think. And in my time with National Archives, one of my major complaints is there's never enough metadata in any of these archives. It's just a big pile of numbers. And without this metadata, it's really hard to do anything with it. I can't say that we see that a whole lot. Our issue is that we have a pile of metadata internally that we have already entered, and getting it from our database into your database seems very redundant in effort, and that most of your inputs are a photo at a time. I have an archive of 5,000 photos, all with usernames and locations and captions that I'm not going to submit one at a time.
Yeah, understood.
But the point is that BADM's really difficult. It's very important. I think, you know, compared to a lot of things, Ameriflux is doing a much better job than anybody else. So, and I'm happy to help anybody who's got questions about it too. So.
Thanks, Joe, and thanks for, I just wanted to point out, Joe has been great at testing out some of our new ideas, so we appreciate that, and other members of Dennis's team as well. Thank you. Thanks actually to for the whole network. We really try to do a lot of user research and understand what's working and not. So these tools that you've seen have pretty much gone through at least some limited user testing, and we really appreciate all the feedback that the network gives us to help make this easier.
Yeah, I had a question, just if in this BADM tool there is like a link to link to external sort of data, like our website, for example, if we could just, I mean, we could almost put in on all of our sites, just a link to our internal
Yes.
photos and information and all kinds of
Site
things.
information set has a
Yeah.
website.
So that's in the site general, so you can put a link to your projects.
One caveat to that is, the idea of BADM is to make it machine readable. So that's one of the reasons why it's complicated in a way, because the structure has to make sense for someone that's loading that automatically for processing a large number of sites. So if it is a pointer to all of the information that would be BADM, that's less, yeah, exactly. It makes it a little harder to reach that information.
For my personal opinion, Ameriflux is like the beauty of Ameriflux is the diversity of science, the diversity of instruments, sites, people, and on this sense, the BADM is so important. So because to scale, because of course every site do the instrumentation focusing on their science, but as we upload as a network, we want to scalable this data for more science all over the world, and for this BADM is essential.
Yeah, agree. We've been, I think, you know, our latest campaign, BADM campaign has been the variable information and variable aggregation, so we can get the OneFlux processing going. You know, I think we like to lead or follow the community, so if there's there's an initiative or a BADM group that could really benefit an effort that's going on in the community, we welcome folks to talk to us and we can help, you know, make an effort, I think, to try to, you know, help get that data into the network. I think that's the working model we have been using or put forth in the last
Somebody was asking, I think on the chat yesterday, if there was irrigation data.
Yeah,
Is there a slot for that at
Yes,
the
there is.
field operations page?
there, it's in Batum, let's see if I can show it to you. Let's see.
I worked with Nebraska sites. It looks like it's one of most Batum agriculture completed information site. They have like fertilizer, pesticides, irrigation.
That's
You can put all the
that's
information.
the Lincoln sites at Mead, yeah.
Yeah.
That site is really great because the farmers are supporting the science and not the science going to beg the farmers to let them on their field.
So I wanna
yeah,
show you.
Mead is excellent.
So this is what I wrote in the reply to the question yesterday. So in the site general info type, there's a general disturbance group. So first of all, this is where you would find information on that the site is, has an agriculture management regime. So you might try to, if you're looking for irrigated ag sites, you might start by filtering sites with this ag general disturbance and management bottom variable. And then for the irrigation, it would be under this, so we have a large, so these disturbances are very detailed oriented, and you would look under the water group for the water management. And here, so you can see what I'm doing here, like just sometimes we have variables that have predefined options, right? Like, so here are the predefined options for this water, and here's irrigation. So this would be an irrigation information. You might get some information on when it happened, maybe just a single date, but maybe a start and end date. You might get a comment that said like what type of irrigation was applied, you would hope. But again, as Joe mentioned, these data are, historically it's been very difficult for people to have the resources and time to submit to the network. So we don't have a lot of this type of information. It's not complete across the network, I would say. Some sites are able to do a pretty good job of submitting what they have, and it just depends on the site and the resources and the complexity, and so it is a little hidden on what they're doing.
I think there are also sites out there that just don't wanna have that public, that they use pesticides or whatever, it's not brought up that word.
100%.
So yeah, and they might not want to have
That's
that
right.
publicly available. Or accessible, sorry. that
Or
is-
water information too,
Yeah.
in some places in the country.
Yeah, it's true.
Sensitive.
This is all new to me because it's all handled HQ Boulder with Neon. Is there anything I can relay to people at HQ as to like how we're submitting our data and through this?
Thank you for asking that. I think we have a pretty good connection with you.
Yeah, we're working with Dave Dutton on helping out with the variable aggregation pattern. So we are, for some of these larger networks, we are trying to work with them independently, try to get lots of data. So Joe, if you have like tons of data you want to share to us, we are open to discussion and how to make that process a little easier, because we realize that the network has smaller teams and teams which are smaller, and we don't have a one size fits all approach at this point. So yeah, reach out to us, we're happy to have this discussion and make your lives easier.
Wondering if like folks who have submitted Batum had advice for folks who haven't. Things that you found, or Joe's given us some tips, about other folks.
Well, one of the things that is a stumbling block for us is that a lot of the stuff that Batum wants are sort of aggregated values. And so we have veg height, but we took 20 points on a transect, and what's wanted in Batum is the average and the standard deviation and something like that for the single day. And so what we store internally is the 20 points. And so to map that into Batum, I now have to go through some hoops to do averages and standard deviations and sometimes there's decisions that have to be made on how to aggregate it and whether it's a different measurement or it's the same measurement or are there multiple measurements that should be submitted to VADM for that particular sampling campaign, and that makes it difficult to build pipelines to do it all the time, and that there's some place where a human has to come in and look at it and say, how do I split this up into, should I mark it as green and dead, or just lump it all into one, or
Yeah, thank you for bringing.
that's one of the
Yeah.
places that really, I get excited sometimes and say, oh, I'm gonna submit all this, and then I don't get that. Because I have to start making those decisions, and then I have a month, a year of data to submit, and then I have to think about, well, what did we do 5 years ago? That I need to make sure I do it the same, so that when I do that again, next time, it will make any sense, so, I don't think there's a way around it, and that, starting with new towers, you guys would be much luckier, and that most of the stuff I'm dealing with have 10, 15, 20 years of data that when you start thinking about how to submit it and start looking to see how they made a measurement 10 years ago, and nobody took any notes on it, just that, so yeah.
Thanks for bringing that up, Joe, and mentioning that, and I wanna reiterate that, yeah, any of the kind of ancillary data, VADM is designed for averages. We could put multiple days, like if you sampled multiple times throughout the season, that VADM can handle, but we are looking for like the footprint kind of representative values here. And that's just a decision that was made at some point for what we could and couldn't support. But it is tricky. I will point out that on some, and I'm gonna show you our like best example. So what we tried to do to help with some of these decisions is give examples of these different variables and how you can think about it. So one thing, especially on the statistics, there's a lot going on how to report the statistics of these variables. And so we put together quite a few examples of what your sampling might look like and how you would report that in the group, different groups. Another idea that we would love to build on, and we were hoping to partner with some site teams to help us do this, but would be to actually design more examples for the different variables themselves. So for example, canopy height, we have a pretty good example here of how we expect canopy height to be thought about, and how you would measure it and report it, et cetera. But that's not available for the vast majority of VADM groups yet. So it's something we're looking to build out and get help with from the experts that are doing it. Anything else from other people who have submitted VADM advice?
Just from my experience, it's challenging to really, from a data provider perspective, to really script a lot of the inputs from whatever you're starting with into the ADM format, just because of some of the data you may be working with for like agricultural stuff for some of the fields I have. I'm just getting notes from someone, and so I can't just write a script that says take how many grams of this was put on the field and tag it with the date and all this. So it's really manual. So because of that, I think my big tip would be to just take notes about how you're doing that, how you're building your files, because it's not something I do every day. It's not something I do every month. It might be every like 6 months I'll be submitting a VADM. So I don't remember how I did it, and because I can't automate it, I'm trying to avoid relearning how I did it 6 months ago to get it, so that when I send it to Ameriflux, they don't send it back and be like, why'd you do this? So just take notes, because it's not, if you don't do it regularly, it's easy to forget.
Alfonso, thank you, Steve.
No, I am looking here in the band standards, site general information, tower power, for example. So it's, can you show that, the last one?
See, even those of us that use it are discovering new things.
We can add something here, or
So,
that's
so
why.
this is an example where this is predefined options. So these are the options you have here on the table. So when you, and this is when you would report on that metadata editor. You can either do it when you register your site or you can update it on the metadata editor. So if you're doing it on the Excel template, you gotta make sure you get pretty close to one of these so we can know which, if, you know, ideally you just copy and paste from this list.
Is there another option?
Yeah, there's an other,
We can
so
add
other
another.
down here. And if we, at the very bottom of the list, there's an other, if you scroll down.
Okay.
Yeah. But so often if you see an other option, you know, try to pick from the list, and if you think you're close and you don't really know, just send us a quick email on Ameriflex-support. But we do look over time as new things evolve, we will update these lists to follow the advances in measurement technique and technologies. So we do try to keep up with what y'all are doing. Secret, any tips?
No. No, I'll bring up the images in my presentation.
Great.
In a bit.
Oh, I meant as a Batum submitter,
Adam,
as a site.
I made mention to Daphne that I know that list existed. Oops.
These are pretty rich pages, so look for things that you can click. All these eye icons have lots of stuff hidden. There's a Batum Basics page. If I can get out of it. With key concepts, tips that we tried to collate to help, because it is complex, like you said.
There's one tip that maybe we as a team should improve as well when it comes to the instruments. They are like to give more examples of instrumentation, especially I will mention later as well, like when it comes to soil radiation measurements, there are some instruments that are classified class 1, class 2 radiation sensors, and so we should add some examples on there, because those are like those really hardcore, precise instruments that, for example, ICOS is using a lot, but are not very common, I believe, in America. Because sites just like add like nitrodometer or something like that.
Yeah. This is the instrument list here, and you'll see it on the variable information tool when you get in there is extensive. The cool thing with the variable information tool is we have you select from the huge long list. Just the first thing you do is you pick all the sensors that are at sensor types that are at your site, and then when you go in to fill out your variable information, you're only picking from the sensors that you know are at your site. So it's the stuff that Sigrid is talking about is first figuring those complex ones out, but once you figure that out, you kind of have it saved for your site. Any topics to discuss or?
Any last questions, comments?
I have a Batum adjacent kind of question. So we talked a little bit in our lab about the citation process for getting our work cited. That we've done. So we wrote a data paper and published it particularly for this purpose. And we were wondering if there's maybe some sort of way, or if anybody's thought about when you do an Ameriflux download, maybe getting a site by site like list that's already formatted for citations to make it easier to cite the data after you download from multiple sites.
Yeah.
Instead of having to go through individually and grab references from each particular site, maybe in the zip file or something, when you download a bunch of sites, have something like that.
So let me show you how to get that info. So here we are on the data download page. I'm just gonna grab some base data here. Gonna get CC BY, and just click on a network BATM file just for kicks. I'm gonna pick my standard test data download site. So I've moved it over. Notice, I just want to point out, there's lots of ways to pick this list. You can, if you have site sets, you can pick your site sets here. You can type out a list of site IDs. You can go back to search, filter, then come back. You'll have to kind of start at the beginning, but you can bring stuff from the site search page. So there's quite a few options for how you get sites that you want to download, but you're going to get whatever's over here in this box. I'm just going to say other. I'm doing the data like demo. And then I got to go say, hey, I read this CC BY, where I'm going to, for each Ameriflux site used, provide a citation and acknowledge the Ameriflux data source. I am encouraged to go contact the site PI. Good stuff. Okay, so here's my download set of information. So here's the actual site data. So this is that zip file that has both the base file and the BATM for US ARM bundled in it. Here's that network level BIF file. So this is all the BATM for all the sites that have base data. Here's where I could go get the measurement height file. Actually, it just downloads it. You don't have to go anywhere, it just downloads it. Now here's a bunch of extra information up here. We have a general README about what you're downloading, a list of the requested files that you've downloaded. Here's the citation. So this is a file with all that citation information in it.
Is it, yeah, so if you did multiple sites,
It's all in there.
it's all in one file? Oh, cool, nice, I didn't know that.
Here's the team contacts to say you want to contact all the PIs for all the sites you just downloaded to say, hey, I'm doing this with your data. What can you tell me? Here's a copy of the license that you selected, that you agreed to when you downloaded the data. We can have a look at this and see what it looks like. I'm gonna just share my general screen and you're gonna see a mess. We're recording this, right? Actually, let me open it. This is interesting. Okay, got it. Okay. So this is only going to show one site, right?
Right, yeah.
But you can imagine. So here's some caveats up at the top, but then here's the site ID. Here's the author list. Here's the title, publication year, publisher, DOI, DOR, UL, and then here's the full citation in the format we chose just for the citation, right? And this is the same as what you'll find on the DOI of the site page, site info page. DOI will have the same citation on it.
And so if that was multiple sites, it
Just
would
with
be,
each,
so it would still have to kind of go line by line and copy and paste.
or write a little script to.
So the site sets as a text file format you could also use as well, and you just copy it directly.
Okay, cool.
Yeah, so we have multiple ways of going about this, maybe not the best, but yeah. It's
It's built in there, I didn't realize it was there. Yeah, thanks for showing.
Yeah.
Through the site sets, you can actually get the bib file, the ref, what's the year?
The RSV file.
RSV, yeah. you can
Or
get all the
RIS, sorry,
citation.
RIS.
Just,
And citation for-
that was
We have a big text?
Yeah, good text. Big text, yeah.
This is the example I showed here on this site set page. So this was the site info and citation. So it's a zip file with all these different options in it for different citation tools.
Okay,
Yeah, just a quick at the end, I would like to add something else regarding BADM as well. On the main site information page, there's also like a publication tab. Please add publications to that one as well. Just pick one site, and on the front page there's also publications, so people can also add publications.
Right.
Please do that.
You want me to actually go there? Or you want me to walk away?
alright, we're a little behind time, but we're gonna shift to our next stop. Thank you, Daniel, for the panel talk. So Gilberto is gonna talk about the one flux processing, and this is the pipeline stage, but the resultant product is FluxNet, which I think a lot of you care about.
Thank you, Wei. Let me get this screen share going here. Okay, great. Okay, cool. So what I'm going to tell you is about this kind of last step of what we do to the data, all of the data, all the metadata that comes into for Ameriflux, and it's using the OneFlux pipeline. So this is the name of the code, and the product that comes out of that is the Ameriflux FluxNet data product. Other networks will have a similar product. They are also using the OneFlux pipeline to do the processing, and they have their own version of the results. So you have the IQOS FluxNet product, OSFlux FluxNet product. So this is the way for us to kind of identify where that is coming from. And I will just enable this here. Let's see. Okay. There we go. Okay, great. So just a quick look through what we're going to see. So what is the FluxNet data product? So for Ameriflux FluxNet, how to get this your site ready for this processing. We're going to see a few examples of variable aggregation. So there are a few things that can be tricky to organize, and Sigrid has been doing a lot of that work, so she's going to tell us about that. And how we are using this information, a little bit just how we are applying the variable aggregation to generate the footprint level site representative product, and how to access the product finally. So what is the FluxNet, Ameriflux FluxNet data product? So this is an overview of the OneFlux pipeline. So these are all the steps that are implemented into this code. This is a code that is freely available. It's an open source code, and it is developed in collaboration with other institutions, mainly with the partners in Europe, but other regional networks are starting to contribute to the development of this code as well. I'm not going to go into the details of each of the steps, but very kind of in a very simplified view, we start from the measured data. So in this case, NEE. We do a step that is just gap filling, so just filling out those data points that are missing. We do the flux partitioning for the CO2, so NE partitioned into respiration and GPP. We use a couple of different methods for this partitioning. And finally, we add some measures of uncertainty that are coming out of the processing itself, right? So in this case, we are showing here the uncertainty that's coming out of the USTAR filtering, and I'm going to talk a little bit about that. Well, actually right now. So the reason I'm going to mention this example is because the USTAR filter is the USTAR threshold estimate, and using these estimates, these thresholds to filter the data is probably one of the most contentious debates that are still going on. And it's one of the main sources of uncertainty that we add through the processing. There are
other sources, of course, but through the processing, this is one of the main sources of uncertainty. So how are we dealing with that in the processing? Basically, we are generating these, we're using bootstrapping to generate all these different versions of what that threshold would look like. So if you have any bias on the gaps that are being propagated to the data set for your site, we can try to sidestep a little bit and don't be biased on the threshold estimation as well. So we take this approach, we calculate basically 200 versions of these thresholds using 2 different methods, and we generate these percentiles of the range of these thresholds, and we generate all of the products coming out of this step, all the products coming from here to the end of the pipeline. We generate a version for all of these versions of the USTAR filtered product. And we also generate some versions that are a bit more friendly to use, so the mean version and a reference version. I want to tell you a little bit about that. So all of these results, they are propagated to the final product that we publish. So if you download the full version of the FluxNet product, you will have all of these different versions from the 5th to the 95th percentile, all the reference version, the mean version, it's all in there in the data set. And just to take a look at what these steps look like. So this is just for one site. Each row here is a single year of data for this site. The 2 colors are the 2 different methods that we use to estimate the thresholds, and the distributions are the distributions of the actual threshold. So at which point we are filtering the data for this site for each of these years. And we can see that the 2 methods in some years, and this is the same site, it's a single site. For the same site, the 2 methods sometimes will be fairly similar, will give us fairly similar results, but other conditions it will be pretty spread out. But these methods are compatible enough that we can basically just combine them and generate kind of a pool of all of these versions, and we propagate the results throughout the processing. And just kind of showing why this is still, there's still a lot of debate here. So this is showing all of the USTAR thresholds for the FluxNet 2015 data set. And each data point is the range of thresholds for one site. And the order here is basically just a ranking of how high that threshold is. So there are a few sites where the eddy covariance method works very well. So you have enough turbulence most of the time, and it's the thresholds are very low. You filter very little of the data. But there are, as you can see at the end here, at the end of this range, there are sites where it's much more challenging to apply the method. So you have a much wider range of thresholds that we have to apply, and particularly very high values. And so we end up filtering out a lot of the data. So that's why this we try to pay so much attention to this particular step in the processing. And then just coming back to that idea of kind of spreading out and generating all of these different versions. So if you just want a simple choice of what you use, our recommendation is just use the reference version of all of the products that we generate. And what is this reference version? So we use this idea of this model efficiency to try to figure out which of the versions, which of the realizations of the based on this USTAR threshold, which one to use. And the idea here is basically we compare each of the versions against all of the others, and we pick the one that is least different from everyone else, right? So this is probably the one that's the most correct. So this way we avoid smoothing the data set with an average approach, for instance, and we can still use with a fairly good confidence which of these versions we should be using. And one note here, we redo this process of evaluating the model efficiency for each of the products. So the reference NEE that we pick here will not be the same version of the reference GPP in the partition product. So when we generate the GPP, we recalculate the model efficiency and pick the most representative GPP. And just to show you what the effects of these of this processing look like. So this is net ecosystem exchange for 2 sites, and you have the mean, the reference, and the version that is coming from the 50%, the median of the U-star thresholds. They're all shown here. They are the different lines, the colored lines. The gray ranges are basically the full range of the versions of the coming from the U-star thresholds. So it goes from I think 5 to 95, 75 to 25 to 75, and so basically just stepping through the colors is a wider range of coming from these versions. And for some of the sites, like this site in Finland, the range of values is pretty tight. So the U-star filtering is fairly easy to apply in this case, and it gets us fairly consistent results. But other sites, like this one in Switzerland, the method is a little more challenging, so we have a much wider range of values that are coming out of this processing. And just looking at the impact of this on kind of further down the line, so this is showing the ecosystem respiration coming out of the partitioning. So you still see that range of values coming out of the U-star filtering, but you also see some interesting effects like this site in Italy, where the 2 different partitioning methods, so in orange you have the nighttime method and in blue the daytime method, they are both very different from each other. So this is coming from the methods themselves, but the impact of the filtering, the U-star filtering, is different for both of them too. So this is something that we are actively investigating, trying to understand, and trying to come up with better methods to increase the confidence on all of these data products. So just to give you an idea of what happens with this processing all throughout these steps. And in this example here is one of the sites that we were mentioning before, one of the lead sites. It's an agricultural site. So we have very low uncertainty for the net ecosystem exchange here. So we start filtering, it's working very well. The gap filling is good quality as well. I forgot to mention that, but this blue shaded area at the bottom is the amount of data that is actually available for that period. So at the beginning there are larger gaps, but in the middle it's pretty good availability of data or high quality gap filling. But even then, we do have a high uncertainty coming from the U-star filtering in the end product in the partitioned ecosystem restoration, right? So this is just something to keep in mind when you're using the data set, or what is being generated for your site from our processing. This is the same as an example as before, but this is just to show how challenging some of these sites are sometimes in terms of generating these final products. Okay, so what do we need from the site to be ready to generate these products, right? So basically there is quite a bit of information on the website detailing some of these things, so I just want to give you some pointers where to go find this information. So if you just go to About Data and in the data menus there, you can kind of track down all of this information. And this is a diagram that Halson showed yesterday. So this is also available in the documentation, so kind of explaining all of the steps. And specifically, there is a page with the details for what's happening with the OneFlux processing. And so all of the information that I'm going to show you here right now, it's all available there as well. You can go back and just check that at any point. So just a bigger version of that workflow. So what we saw so far is the process of getting the data from the site through the format checking that we saw yesterday, the data QA/QC checking we also saw yesterday, And we published that base product. And with the additional BADM metadata that Danielle was just telling us about, we can do the one flux processing step and then get to this FluxNet product that is published later. So basically for the QA/QC that is applied for the base, there is kind of a focus more on the general data quality. So it's trying to understand the levels of quality that are, the quality checks are kind of more general, looking at the overall data set. While for the OneFlux product, we are looking for some very specific points. So for instance, if you have very large gaps in the air temperature, we won't be able to really generate the nighttime partition product. So these kinds of things are things that we are looking for, and you might hear back from us questions on this. So for the base product, we are using all levels of aggregation. So all of the data set, all of the data variables that are sent, they are made available, they are published. For OneFlux, we are kind of combining everything into a footprint representative version of those variables. One thing that it's always good to mention is this data set, this FluxNet product is compatible with, starting from the FluxNet 2015 product, these are all backwards compatible. So you can kind of combine data from multiple sites from that generation of the product with these new versions that we are generating. Okay, so this is everything that goes, that needs to come from the site to go into the OneFlux processing. So there is some configurations that we create for the execution, but basically we need the base product published. We need the site general information. We need to know exactly where the site is, the time zone. So this kind of information is necessary for the processing. We are kind of combining products from different locations. So it's important for us to know the exact location and time shifts that are applied. And then the two big ones that Danielle mentioned are the metadata for the variables, so measurement heights or variable information, and the variable aggregation, how we combine all of these data sets to generate the OneFlux product. Let's see if there's something else I need to mention here. Yeah, so one thing that we should pay special attention to, and we can come back to that later, is how to handle CO2 storage. So we have a method implemented to handle sites that don't have a storage, a profile of CO2 to be able to calculate the storage. But ideally, for sites that are usually higher than about 3 meters, it's important to have the storage management. And as Stephen mentioned yesterday, there is a loaner package just for storage if you'd like to try it out and see what's the impact for your site. Okay, so just going through the variables from the base product that is published, we have a few variables that are absolutely required. Without these variables, we really cannot generate any product for your site. So these are things like the CO2 concentration, the basic fluxes, the storage, and there are, if the tower is not impacted too much by storage, that we can be flexible on that. But all of the fluxes, wind speed, the U star, of course, temperature, relative humidity, pressure, and radiation. Ideally, shortwave, but if you only have PAR, we can also make that work. And then there are a couple of variables, 3 variables that are actually just 2. The 2 variables that are recommended, and this means basically if you don't have these variables, we'll still be able to process your site, but we will not be able to generate a few of the products that are part of the pipeline. In particular, in this case, we have the soil heat flux and net radiation. If we don't have that, we cannot generate the corrections for energy balance exposure for your site, for instance. And then we have a few variables that are suggested. These are variables that we use to do quality control, to do comparisons. So it's very helpful to us to have these variables, although they are not part of the products themselves. We still publish these variables in the final product and we use for quality control, but they are not used in the automated processing. And yeah, just a couple of notes. We do calculate VPD from the temperature and relative humidity, so we don't use the VPD that is coming from the site. We know that there are pros and cons on doing that, taking that approach, but we are trying to make the product as consistent as possible, so we opted for using this approach to derive the VPD. And for the soil measurements, we basically take the approach of trying to provide layers of in the final product. So we aggregate all of that into this idea of layers. I'm going to mention a little bit more about that in a minute. We saw a lot about this already. So the two main pieces of metadata that we need for the processing are the variable information, and Danielle just went through a lot of detail on this. So this is just a view, very shortish view of what is available for one site. So you have the variables, the heights, the instruments, when that variable started. So we use all of this information in the processing. And then the other product is the variable aggregation that Danielle also mentioned. So this is the same diagram that Danielle just showed. So just to kind of remind you that these are the two important pieces that we really need to get started with the processing from the point of view of metadata. And now we have a few examples of how these the variable aggregation part looks like. And just because there are a few tricky points that might be useful to know ahead of time. So, and Sigrid is going to tell us about it, because Sigrid has been contacting the sites and doing a great job of compiling all of the information and making this available for processing.
Yeah, so so far I came across simple sites that are very easy to process. You don't even contact the PR, we just push them through, and the next thing is they get an email saying like you've been published. So in this case, as an example, I have a site. We know now we have the list of what is required. It's over here, the variables. This is the base data that was submitted by the site. We see single observations of all the variables. I look at the variable information table of this particular site now. I can see they have all the variables in the table. They have nicely filled in the measurement heights. I can see in this case, the site is 3 meters tall. So the measurement height is 3 meters. So in the aggregation file, I can write, obviously, no need for storage calculations. So these sites are ideal. We have all the information we need. In this case as well, the site also had filled in the instruments. So these are the simple, straightforward, type it in, submit. Next thing is like, go through the pipeline and not being published. And there are sites that are a bit more challenging. So this is a site that has a lot of measurements. You can see here a lot of soil temperature measurements, and as you just heard with below ground measurements, we can layer those. They get aggregated by the same DAX. Like in this case, ideally you see here with soil temperature, these three measurements are at the same DAX because I have this the information in. I can extract information from the variable information table that the site has filled in. And again, here I can see with storage, the site does not require any storage calculations because I have the information, the measurement height again, I could extract from the site, from the variable information table, sorry. Then I have sites that, again, if you only look at the base data, I see, oh yeah, they measure also several depths of soil temperature. I can have all the other measurements that we need. I then go into the variable information table and then stumble over a problem saying like, oh, wait a second. According to the qualifiers I've heard yesterday from Danielle or when we gave the presentation yesterday, they have a profile. So yeah, my aggregation file would then have all these different tags. But if I go into the variable information table, these are all been measured the same height. So what is not correct? Did they make a mistake with the naming of the variable by classifying it as a profile with, like, you see location 1, that's 1, location 1, that's 2, but that does not add up. So in this case, I have to then contact the site PI and say like, hey, which one is the correct information? So sometimes happens, so like, oh, oops, and they then correct and resubmit all the data. So then we have to wait for the data to pass QA/QC again, and then be published in base first, and then they can be pushed through the OneFlux pipeline. And in this case, again, we can see from the momentum flux, we can see they measure 7 meters height, which means they would have a storage. And in this case, they have storage measured, so we just automatically use the variable that they uploaded. Sometimes people do not measure, so what we do then, we use then the CO2 concentration as a replacement and treat it as, I believe, as a 1 point measurement. Yes, one measurement, exactly, yes. So these are the challenging, it's a lot of like back and forth with the PIs, it might take a while because they then resubmit the data, so then again, this side is not that straightforward, it takes time. Then I come across other sites that have submitted lots of variables, but then I go into the variable information table to extract to see, are these now different locations, are they measured the same height, or is that a profile? And then I look at the information table and it says no records found. And it's like, yeah. So then what do? You send an email to the, I then have to send an email to the PI and say like, can you please complete the variable information table? And then as a help, I can then add their variables from the base file, just as a reminder and a bit of a help. Or do I just go straight forward and pre-populate the table myself? That I, from experience, that was quicker. If I just pre-populated it and then sent the PI name, I was like, please. And then to be even friendlier, I then look at the images that I find, and then pre-populate the instrument types. We have also a few sites where are old sites, they are not active anymore, where the PIs moved on. In one case, unfortunately, the PI passed away. We have no information about the site anymore. And in cases like that, and if there's no image on the variable information, the site information page, I then go into the publications and see, can I extract any information? And then for one of the sites, I managed to pretty much recreate the entire variable information table from the site publications that I found. So, and if there are sites that, as you saw, there's a whole list of required variables. If there are sites that have some of those missing, I get in touch with the PI, explain, look, you have submitted all these variables, but it's not complete. Are you willing to resubmit the entire data set and add the missing variable onto? And I came across relative humidity and, pressure and the CO2 concentration to be the two variables I have to then contact the PI and say, are you willing to reprocess, resubmit the entire data set and add this variable? Or they have only submitted a variable the last 3 years, but the previous 10 years they have not. So in cases like that, we'll only be able to process the last 3 years and then disregard the first 10 years. So in cases like that, PIs are then willing to reprocess the data because they have not measured, and then they calculate let's say relative humidity now, and then resubmit all the data and add in the variable information table in the comment section that from this year to this year has been calculated. So the users know that, because the users would like to know where was measured. And then obviously a site like that, we again have to wait for the QA/QC process, base, publish, and then push through OneFlux, and then has the entire time series in base. So far, I came across 2 sites I contacted that said, no, I would not like to be included in the OneFlux processing. mainly because of missing variables, that they were not willing not to resubmit the data, but they had recognized that their concentration values are not good enough to be, they're good enough for fluxes, but not good enough to be submitted as CO2 concentration. So we had 2 sites so far that they said, like, please remove us from the list. So yeah, and then again, lessons learned, more advice from me is like, try to keep your variable information table as complete as possible. Add comments where needed, like in this case, the PI said from this and this years it's been calculated. Add when you change the heights, because we had also like sites that we had to then pull out quick because the variable information tables had like the heights of 4 meters, and actually in fact they measured 11 meters now because they had to gradually increase the heights. So then they had to go back and complete the variable information table before we then bring them back in. So yes, pay attention to qualifiers, like I showed before. Don't use a qualifier and then it turns out actually well they're wrong. And keep the site information page updated. Please add images. Please add publications, because that's very helpful in this case. That was very helpful to me. Like I said, with sites that we have no contacts anymore. Yes, there's the link to the bottom tab, and I saw a few of those today. Maybe we should actually send out a list with just all the links that we've shown. And then, of course, when you fill in your variable information table, just pay attention of what type of measurements, what type of instrument model you're using. And the most common one that I came across was the use of the incorrect radiometers when it comes to incoming and outgoing shortwave and long-wave radiation. Because there is very distinctively the net radiometer, which is just measures net radiation. Don't use that in your, if you have incoming and outgoing short and long-wave radiation, because that's the incorrect instrument model. So yeah, I think this is the most common or the most frequent mistake I see in the choice of instrument people use.
Great. Yes, thank you for that, Sigrid. So one thing that Sigrid mentioned was some sites have kind of long records, but they were not measuring all of the variables for the initial period of time that the site was deployed. So we need some flexibility for a network like Ameriflux. And one thing that a few sites have opted doing is to use measurements from a nearby station for some of these variables and send that in kind of in place of the measurements that would be made locally. So this is not ideal for many of the variables, but it allows us to at least get some use out of the other data that was collected at the site. So things like that are options. So for a lot of these conditions, we have kind of alternatives that we can suggest for how to get the site ready and included into the processing.
In this case, it's air pressure.
Air pressure. Yeah, for instance, air pressure, there's a lot of measurements that are kind of close to airports that you can kind of interpolate and get pretty good approximations. So those are things that we would be able to take as kind of a replacement value for the variable. All right, so how do we use these variables? Just a couple of very quick examples here. So this is an example of CO2 concentrations for a site, and they had 2 measurements of concentration at the top of the tower. And in this case, basically both of them were considered reliable measurements. So we just taken all of the time series for both, and we minimize the gaps that we will have in that time series. So this is kind of the simplest mode that we can have that. And this is a view for the soil temperature measurements. It's a pretty similar approach. So we get the rules from the variable aggregation information that was sent, and we just apply this operation across the variables and generate the kind of the different layers of soil temperature. So there is really no magic to what we're using, how we're using the information is pretty much what is in the rules that are in there, we are applying here. And if there are rules that are changing through time, so for a period you want to use 3 of the sensors, and for a period you want to use all 5 because then you replace 2 of them and they are reliable now, we can accommodate all that. So you just have to tell us the timestamps where these changes happen, and we'll incorporate that. And finally, this is the last part here, is how to access this data set. So you already saw this download page a few times. There are just a couple of extra steps for the Ameriflux FluxNet product, and I just want to mention that. So you select that. You have 2 options of 2 versions of this product. One is we call it a subset because it is a subset of the variables. It's not the entire range of variables that we generate. So it's about half of the variables. They actually have the number here. I forgot about that. That's cool. So 120 variables you download when you get the subset, and up to 242 variables if you get the full product. And the full product basically has all of the variants, all of the instances of the U-star percentiles in the individual percentiles, if you really want to understand the uncertainty coming out of that step, for instance. Again, here, just to select the sites, Danielle mentioned all of the different options to select that, and agreeing to the license, and getting all the files to download. So in this case, one difference from this is that the ADM information for the sites is not yet included into the individual downloads. So you do have to download the full VADM for this product for now. We are working on incorporating that into the product. Yes, yes.
I just want to add something that I've totally forgotten to mention. I apologize about that. How do I do that? This way. For example, when it comes to the aggregation files, obviously if it's site like that where we have all the information, we then just push through automatically. But there are many sites where they, for example, like let's say air temperature, they measure at several heights or have several several measurements of the same variable. In this case, we only pre-populate the aggregation files where we can, and then send those files pre-populated to the site PIs and say, like, hey, can you please choose the most site representative variable amongst from those variables that you are measuring, and then they do submit those files directly to Ameriflux. So I've just got the information.
Oh, that's great. Thank you for that, Sigrid. So that's what I have for the processing. Happy to answer any questions. One thing that I will mention is, and this is something that comes up often, is why don't we use X method to do gap filling or do partitioning, or why don't we implement this new change to this method? So the way that we move forward with the development for OneFlux is to make the codes work consistently across the broadest range of sites possible. So before we add a new method, before we make a change, we really do a very thorough evaluation of how that's impacting on the site. So making this product across sites, making the sites comparable is very high up in our priorities. So that's why sometimes there are some innovations that are not necessarily reflected yet in OneFlux. So for a few sites, there are methods that work a lot better, and you should use that. But if your goal is to really do a comparison, do a synthesis across all the sites, then we think this approach that we know works consistently across this whole range of sites that we have is probably a better approach. So that's one thing that sometimes comes up. But other than that, that's all I have. Any questions? I know that's a lot to take in, but hopefully it's a useful question.
And how long does this process take?
Okay, there are several steps. So for the longest step of the process is gathering all of the data and everything, right? Making sure that everything is correct and everything is ready for processing. So for an easy site, that might be maybe a couple of weeks of interactions and making sure that everything is in there. For a site that is a little harder, I think we have a few sites that have probably been going the discussions for over a year that we're still going back and forth trying to figure that out. Now, from when you start the processing for the actual, so you have all the information and you start the processing, that varies quite a bit too. So there are a few sites that are very easy to process. So within 1, 2, 3 hours, you have the final product available. For a few sites, there are some steps that take a lot longer. The partitioning step is the one that's really tricky sometimes. It's trying to do an optimization, trying to find relationships, the optimal relationship between temperature and natural system exchange or temperature and light response curve. So it's doing that optimization. And if you don't have a lot of variability in your temperature, for instance, your site is very constant, it's very hard to find the optimal point. So I think the longest running site that we had with the actual software running was about 14 days. It was one of Sebastian's sites. It's very stable temperature, very hard to find the right answer. So it varies a little bit. But this is something that we are working on to try to improve that speed of the actual execution. But so far, getting the information has been the most time-consuming step.
So I think what might be a more accurate answer for the question is from when they finish getting you all the information that's needed to when they could reasonably expect there to be a FluxNet product published, what's that typical amount of time?
Yeah, so great point. Yeah, that's the interest. So usually when we have the information ready, we can pretty much start the processing right away. But there are caveats to that. There is one of the steps, and I can actually go back here. There is this step on the gap filling of meteorological variables that so far we have been running that in an external system. So we had to make a request, get the ERA product and do the downscaling. So that sometimes added a little bit to the processing time. We are now implementing that into the pipeline, so that's not running outside anymore. So when that is ready, that answer becomes from the site being ready to being able to publish it, probably a couple of weeks maximum for the running time and
Let's
maybe a
call it
couple
a
more.
Let's call it at least a month.
Yes.
At least a month.
Right. Is that what you had in mind? So that,
Some of the sites end at 2015 for FluxNet, but when you go to Ameriflux, it's got up to 2022.
Right.
So are you still waiting for data in those instances?
yeah, so when we did the processing for FluxNet 2015, all of this information, the variable aggregation, the variable information, we collected that manually.
Okay.
So we did this kind of one-off efforts to collect the information, and we did the processing. So for some of the sites, even though the data are already there, the metadata for us to be able to follow the same process is still not available. So, but this is getting quite a bit better. Sigrid has been making this big push to collect that information, so we're getting up there in the availability, and we'll be able to process many more sites.
Thank you.
It also depends on the responsiveness of site teams. Like I said, I mean, some sites we deal since over a year. I can see that. It's like, should I come knock on your door?
At what frequency will you update it?
That's a good question. We don't have a final answer to that yet. But we were hoping to run sites at least a couple of times a year. And hopefully in the future, as soon as we have new data, we would be just triggering this whole thing, and new data comes in, base gets published, a couple of weeks later, we have a FluxNet product. That's the kind of target, the end goal for this process.
Just add one caveat, so after your FluxNet data get published, or get processed, we do batch publish them on the site, just like the base data, so even though, and we do that kind of every 1 to 2 months for base, so there's also can be some little bit of time there just till we get ready to push everything out. So just a note that it doesn't go immediately to the website. They kind of come in
Batches.
And the hope is, because as Gilberto mentioned, for FluxNet 2015, that was very manual process. We're putting a lot of information in databases. This is getting scrutinized quite heavily. Hopefully, if the site doesn't change too much and the information updated, that process should get much faster eventually. And so we have to make some choices on targeting sites for more data release, but it's an incremental process.
There was also only a small number of sites.
Well, prioritization criteria, that's for sure.
Great. Yeah. Good question. All the data is raw data.
No, for OneFlux, we're starting from the half-hour data. So you would do the processing from high frequency to half-hour, so using EdiPro or any other software, and we start the OneFlux processing from that point forward.
Well, for complete the gaps, if after the processing or before.
It's after the high frequency to half-hour. Yes, that's right.
Another question: if you don't have the temperature of soil in the same side of the tower, and you have another near, or what can we do if we don't have?
Yeah, this is a great question. So as I said, it will depend from site to site. So it's usually a conversation. We discuss that and see if that makes sense. But for some sites, the soil is pretty much the same. The vegetation cover is pretty much the same. So even though it's very far, you can still use soil sensors that are somewhat far from the tower, and that's still kind of representative. For other sites, you walk 10 meters and it's a completely different ecosystem, so maybe not. So it is a case by case decision, but great question.
But in this case, if you do it, you have that soil temperature data has to be submitted as part of the site data. You can't say, oh, I use the temperature from this site when you do OneFlux on this site. It has to be, so you have to submit that data and then add the comments and what has been to say, yeah.
Because you're relying so much on average data, I suppose, and standardized fields and everything, have you noticed any type of data reporting that is not very compatible with the standardized flux processing? Like, we have, at Tonzi, for example, we have 1 million different thermocouples, and averaging them all into one, rather than reporting a single one, I don't know which this system tolerates better, and I'm sure other sites have similar problems or similar challenges.
Yeah, that's a great question. We have been implementing some diagnostics for trying to understand how the aggregation is actually impacting the final average product. And there are some situations where we actually go back to the site teams and say, hey, maybe you should exclude this sensor from your averaging, or consider including this other one because it would add like 2 more years to your time series. So this is an important conversation that we try to have, and generating some of these diagnostics is probably what took us most of the work for the last year or so.
Sure.
So we can understand what data we're feeding into the pipeline. We were getting a lot of execution errors when we were trying to run the processing for a few sites. And a lot of that was the data that was coming in to the processing, right? So doing this kind of just taking the rules blindly and applying them was not really working out. So this is a crucial thing
I guess I'm asking if there's any major don'ts in terms of
major don'ts. So I guess if you are considering the aggregation, for instance, looking at the representativeness of the sensor. So if you have, for instance, a profile of air temperature, you wouldn't want to integrate under the canopy and over the canopy, for instance. So this is the kind of thing that sometimes is a little bit lost in the rule, because if you're just looking at the variable names, you might, okay, let's use this all so we have the longest record possible, but they are very different, so you shouldn't do that. or when you're doing this soil aggregation, for instance, even though two sensors might be exactly at the same depth, the soil horizons are different because they're changing, and so you should take that into consideration. And so not averaging to saying that.
That it's representative.
Right, exactly. It could be, yeah. There are two sites where this is actually happening. So for one layer is just one sensor, for another layer you have 5 sensors, another you have 10, and that's totally fine. It's what makes most sense for the ecosystem. So yeah, keeping in mind what is representative for the site or representative for that layer is probably the kind of the rule of thumb for coming up with these aggregations.
Can I just say something quick to example? We had a site, for example, where I contacted the site team, and which is other people on the site information table, and if they're not on that, then they're not getting contacted. And that site, for example, also got back and said, like, I would like to actually resubmit all the data and include individual depths, not just an aggregated value. So we had those cases as well, where then suddenly we had more data than before, which is good.
I would just add on that too, that we do really encourage folks to submit for the base publication, the individual data streams from each sensor. And it's great if you also want to submit an aggregated version that y'all like, that makes sense. But it makes the data set richer for the user. So if you have that capacity, we encourage that individual sensor level for the base, then you can decide what to do with OneFlex.
Great.
And we have sites that only submitted gap fill data, which again, we have to contact them and say, like, can you also provide the non-gap fill otherwise? And also when it comes to gap filling, depending on the variable and also how the data was gap filled, because in some instances it's being accepted, but most of the time it's like linear interpolation, no sorry, we want a non-gap fill data. If you gap fill with an existing instrument, then that's different. But so there's also that kind of conversation as well about like the gap fill data that you provide.
Okay, cool. So we still have a little bit of time, and Deb, if you're up to it. Deb has been doing some work on citations, and there was a little bit of discussion on that topic just earlier. So getting citations right when you have this many sites is a big challenge.
So just a quick intro, because yesterday Deb joined in, so Deb has been, I guess in the Flux world, first in the FluxTech world for quite a while, I guess.
Since 2006.
So a long time. And then she when AMP was assembled, Deb took the lead of the data team. So a lot of the things that you see come from Deb's brain, right? So she's been really keen on getting this. So and
There were a lot of other people helping.
yeah, but that's and that might be Deb's last data tech meeting.
Yeah, I'm retiring in a month and a half. So basically, yes, this will be probably my last data tech workshop. I do want to talk a minute about citations, because a lot of you marked that when Howson had his poll. I want to kind of talk to him from a couple of different perspectives. So the old guidance that we used to give people is cite the paper about the site. The problem with that, if your people who are, you yourselves and others, when they use your data, if they're using a paper as the reference, you've completely thrown out all reusability, because at that point, that paper doesn't really point to the particular data that you're talking about. So what's much better, yes, whatever, use your paper also, but please ask people to cite the data, use that DOI citation, and include the version number in there. That's what's going to be traceable into the future. We are working hard with the indexers to make sure that those are all countable into the future as well, and that you'll be able to track, how many uses of your data in different papers. The whole idea is that is a valid research product that the people should be citing. So please ask people to do that. So that's step number one. Now, many of you will immediately count up the numbers and go, but there's a problem, Deb. That means you could potentially need to put in 350 references into a paper, right? If you've used the whole data set. I can't promise that we have a solution yet, but we are working on that. We've got meetings at AGU, EGU. We're working with the publishers and the indexers and the technologists. The proposal is basically there'll be a thing called, well, at the moment we call it a reliquary, but where there's basically going to be a type of container where they'll be able to list all the references and then reference them in the paper, but not take up room in the paper with the reference list, so that you don't get the science says, oh, well, you get like 20 references. So, and then, you know, you all end up in the supplementary materials. So two things, that's coming. It's going to take a little while, but please recognize we are working as hard as we can on that to get that in place and with the publishers so that they'll have means of helping authors do that. And the other piece of it, if any of you are interested in sort of following that work and getting involved, if you look at RDA, there's a new working group that we're going to come up with the best practices in the next 18 months. Since your sites are the original use case that generated all of this, I would welcome others getting involved in sort of driving this and helping to bring forward that information. The other thing that I always want to say at every Data Tech workshop, the author list on that citation, as Howson mentioned, is separate from the contact list. So if you are a significant contributor to the data that your site is generating, I would highly recommend talking to your PI about adding you to the author list as well. That is something they can do.
I don't think my PI can do that.
Should do. Some of them may not be technically able, but it is a capability out there that they could